Hello. Alright, we are here on the second channel. My voice is a bit dead, which is expected, but that's fine. Yes, things are going well. Where the hell was Khotan round 3? Were you like up here? I don't understand. Oh, okay, that's fine. Alright, sure. So we were looking for another problem and we didn't find one. Okay. Alright, let me pull stuff up. So this is day 2. Let some people settle in. Cool. Let's do this. Okay. And here we go, I guess. Okay, so actually I'll let other people come in, I guess. Start with that. What's up, Karani? Is that how you say that, by the way? I'm not exactly sure how to say that. Okay, so I've decided to use my brain and not do the virtual at the end of the stream 9 hours in. This may come as a surprise, but I've thought it through. So yeah, I think I'll do it mid-stream because pain. Actually, I'm not sure what the quality is. Yeah, 720p. It's because OBS is like, is 720p that bad? I mean, it's like, I don't know. 720p was always on like the edge of like that's like it's not bad. It's not great, but it's like it's not 480. You know, like it's watchable. I don't know. It's echoing. How's it echoing? Wait, what? Wait, I'm not playing any other sound anywhere. Okay, good. That's how you say it. Yeah. Is it really echoing? That's weird. Okay. Good. Okay, I mean, it shouldn't be. There's no reason it would be. Okay, yeah. So, virtual is going to be mid-stream. I don't know when. Just some when. Yeah. And... Oh, okay, yeah, that's nice. Okay, cool. So... Yeah, I mean, same plan as yesterday. We're just going to do some problems. Oh yeah, there's a little... the links are not clickable because it wants me to verify my ID, and it didn't tell me that until just now. So, sorry. You're just gonna have to like copy them and put them in. It's like fine. Okay, cool. Yeah. So we're just gonna do some more problems. Where were we yesterday? So this one was the unrated one. So what is G? No. Okay. 814 we looked at. Or I looked at. This one is new for me, so we can totally do this one. Okay, why am I opening I have chat on my phone. That's the whole point of it. It's not loading. Awesome. I love the internet. It is beautiful. 1 div 4 and 50. I could actually do that. Okay, The reason for 2 channels is because I don't want like 30 streams of competitive programming, which isn't even my focus on the main channel anymore, to pollute that. That's mainly the reason. 11 hours maybe, probably 10-ish, because I'm starting a bit late. As I progress, I'm gonna wake up earlier, and then we'll have more time. But I do need to not stay up too late. Okay, so we're just gonna do this. Oh god, okay. It's a game problem. Alright, cool. Good stuff, good stuff. Let's start it. This is not, I'm pretty sure this is not 3000. It has a lot of solves, so we'll start with something, should I complete a div 4? Should I start with something easy? Should I start with something easy? I don't know. Probably not. I mean, it's for the sake of practice. I guess I could do a div 4. I don't know, man. Have we looked at this one? We've not looked at this one. I'm kind of tempted, honestly. I'm kind of tempted. I am kind of tempted. I'm definitely gonna do a strategy blog at the very least. Like, I want to, yeah, I want to update my philosophy because it has changed a lot since the roadmap, and I want to make it clear what I'm thinking now. Yeah. So I will definitely do something of that sort. Probably not a video, because like videos are effort, and it would literally be like an hour long, because there's so much to cover. But yeah, I'll describe them later. Once I like, I need to like, they're in my head. They're just like a jumbled mess, and I need to think about them before I can coherently do them in words. Goodbye 2023. I have heard of that contest. I'm glad I did not do it because I'm not good at Googling things, and apparently this problem is only easy because we have internet access. So I would place around here, which is very bad for me because I'm gonna lose like 100 rating. So I'm glad I didn't do that. I'm glad I didn't do that contest. Yeah. Friend did very well, but not me. Okay, we'll do the div 4 speedrun. Fine. And then we're doing hard problems, alright? We'll do one easy round. I'm gonna virtual it, because why not? I'm not gonna beat geothermal, of course, but I'm gonna virtual it. Okay. Wait, this is for that. Yeah. I have a couple of extensions. I have this, which adds a performance column. Ask me in Discord later, and I'll link it. It's just a it's a simple thing. And I have caret, which tells me performance. I have caret, which tells me like performance, like so, like this, and rating changes and stuff. Estimated time. I'm gonna hope for 6 months. That's my approximate timeline, which is not that far, but it's still like there's a lot to do in that timeline. Okay. Okay. Are we ready for the div 4? You guys can do it with me too, because why not? That's the whole point of this stream anyway. So this is round 918. Just go to the contest page, scroll down, you'll find it. Alright. Multi-tests. Okay. We don't have anything baggage. Okay. I'm going to close chat, because sorry, but this shouldn't take that long anyway. Let's do it. And then we're doing hard problems, all right? Because I don't want to. This is not good practice for me. I'm sorry. Okay, I'll one out. So vi if c is equal to question mark, pause equal to 1, r, if pause, yeah, r. Okay. String v3, c to v0, v1, v2. What? What do you mean? Oh, you idiot. You idiot. Okay. God damn. Oh, that was dumb. Okay, that could have cost me a lot. CVC, okay. CN2 and S. Okay, so for I equals 1, I let's go to n, I plus plus. If I is greater than equal to 2 and si y-val. Oh, const si minus 2 pause I minus 2 SP, what are you? T minus par I. This might be off by 1, we'll see. Why? You didn't compile. Yeah, you're off by 1. That's fine. No, it's worse. What? It's CV, not, wait, what? Wait, that's wrong. BAC. No, this is wrong. It's CV and CVC. So you're 3, that's true. The hell? This whole thing is just wrong. So you should be split 5. No, this is still wrong somehow. Yeah. This is all wrong. Okay. Scene down to S, VO pause, VO par, pause 0, VO SP, cons, val, cons, val, cons. Okay. That was weird. I feel like you can greedy that, but whatever. Oh, you can probably greedy that. Okay. Shame. Probably should have thought of that. Okay. Um. Underline if person's at point A. So I mean, you'll meet every BI that's no. You'll meet every interval that you completely contain. And that's it, right? If you intersect, you won't meet. If you intersect, you won't meet. You have to completely contain. Okay. Vector PLV. What are you doing? Sorry. checking the things that are greater than y. Ants plus equals os.size minus os.order of key y. os.insert y. Yeah. Shame. Yeah, no bikes, no bike. Traversing a j using a bike j humans. Okay. Let's do this. What are you? Okay. T is equal to 1, T equals W, T plus D dot edge X plus T times N, Y plus T times N, T times Z. D dot run N times W. D dot dists N minus 1 plus T times N. Okay, damn, we're really just slow on D, huh? Should have thought that through more. Okay, sure. So if we were not so slow on D, which like, yeah, okay. Okay. So what happened there was I had a solution for D, which I thought I could do quickly. It was the DP solution, which is, you know, a thing. I had a solution for D, which was dumb. And then there was a much simpler solution where you just go from the back that I did not think about because I had a solution. And the problem with these like speed rounds is that you have to make snap decisions like that. Like when you have to solve you know problem when you have 2 minutes to solve a problem, like you have to make snap decisions. And I made the wrong snap decision, and I should perhaps spend a tiny bit more time looking for something that's maybe simpler given the structure of the problem. Because I mean, if you go from the back, it's like really simple, but that's a shame. Yep, that's a shame. Whatever. Okay, cool. I guess we'll watch our rank go down as people go faster. Yeah. Okay, cool. Did you guys get your fill of speed forces? Yeah, still some views. It's not bad. I want to only participate when I get like ready for LGM, because otherwise, I don't know. I don't like. Yeah, I want to participate only when I'm ready for LGM. Pretty much. That's the plan. That's the idea. If you want me to talk about any of the problems, sure, I guess. But I don't know. Oh, Taurus got hacked. Wait, how do you get hacked? How do you get hacked on this problem? Huh. Okay. How am I using ordered set? I installed it manually. I don't remember how I did it. There was some blog on Codeforces, but I have it manually. It doesn't benefit me at all. People just wanted me to do it. Okay, I'm caving to crowd desires. Oh, overflow. Damn, that's rough. And they didn't have that in I guess it might have been a weird overflow. Oh yeah, 10 to the 5th. All you need is like all bikes are 1,000 and a path of length n. They really didn't have that in tests. Okay, whatever. Discuss problem G. Right, so this is Dijkstra with states, essentially. You have two states, you have two states. Each state corresponds to a node. Like, the state is the node that you're in and the current weight that you have. Yeah, so... And given those states, I don't know. Given those states, I mean, like that should be enough to build a Dijkstra graph, right? Like given two nodes of the same bicycle weight, you can travel between them at the cost of the bicycle speed times, you know, the weight at the edge. And then at any point where you can get a lower bicycle, you can transition to a lower bicycle weight for free. I'm not going to draw things out because I'm lazy, but if I was in my prime, I'd be drawing out like a 3x3 grid where you have stuff like that, you know? Yeah, I'm not feeling it though. How is bits working? I installed it manually and I don't remember how I did it. There's something, yeah. I think this discussion should have it. There's like something here. I don't, yeah, just search it. I don't like, I don't remember how to do it. I just did it once and it worked and I've never thought about it again. I did the same for ordered set. Like, I'm pretty sure I just installed it manually or something like that. It was something, or no, I don't remember. It was something weird. Oh wait, no. The issue in general is that G++ is not what you think it is. type out G++, and you'll see that it's actually Clang, because Mac decided to name Clang G++ because they're Mac. So what you need to do is, when you install G++ with Homebrew, it's going to be in a folder like this. So like G++13 V. And then suddenly you'll actually find that it's actually G++ and not Homebrew, not Clang. And like that's the issue, that Clang doesn't have it, but G++ does. So you want to find like where the actual G++ is that you installed, and then use that instead. And I think that should work. But yeah, you can also just install it manually. Yeah, I don't remember what I did. I know using actual G++ is like important though. How fast would we have been with a faster D? I guess it was like a 5-minute penalty. So 20, 39. Yeah, sure. Okay, could have been faster. Wouldn't have beat geothermal. No chance of that. So whatever. I think yeah, that's a shame, man. That's a shame. Because if you go from the back, it's so simple. I should have thought like I should have thought slightly more about it. That's the thing about these speed contests. You screw up one problem. You make one mistake and your penalty just tanks. It's such a shame. Alright, whatever. That's enough of Div 4. How do my friends do, I suppose? Flex on them. Yeah. Okay, cool. We got them all first try. It's not bad. Not bad at all. The extra template coming in clutch. Okay, we are doing real problems now. This thing. What do you mean what I'll do in the future? Like in what sense? Like competitive programming or like after? Oh, my job plan is YouTube, actually. Hang on, let me clear my mouth. Yeah, my job plan is YouTube. And we'll see about that. I intend to make it work. It's not going to be this channel. This channel doesn't pay that much, but I have other plans that should work out. Yes, I am streaming for long hours. Feel free to sleep. Feel free to stream with the Feel free to stream with the stream on, so it gives me more views as well. That's very nice. I don't have ads on this one because the channel isn't monetized, but yeah, it's fun. Okay, I'm gonna focus on this problem. Good. Alice and Bob are playing a game. They're on cells in a row, and if we cell to the red or blue, Alice goes first. Each turn, Alice chooses 2 neighboring cells, paints that 2 cells white. Yeah. So these are almost forced, almost, but not entirely. Wait, what? Oh. You can repaint. Okay, that matters. So when you have a streak of blues, So we have a streak of blues, right? So I always put the RR. And this is weird. Bob should win that one, right? Yeah. So Alice moves first, which means she's at a disadvantage. Almost. Not exactly. Well, maybe not disadvantage, but like if we have so we have streaks of alternating. Let's think about the streaks of alternating, right? And at least two. Thank you. So if you have RBR, right? Something like that. Like BRB. Like BRBR, right? BRBR, if we move on the left, then Bob can screw us over. So we consider the start of a streak of alternating, right? So we have RB. This doesn't seem fun. RBR, right? This does not seem fun. RBR, right? This really doesn't seem like it's gonna be fun. Great. It's only freaking 2600 too, so I have to do it. It's 5v5, so I can't even do a log. Maybe, but I guess we don't need to, but like. So man, I'd rather do BR than RR. And they'd rather do BR than RR, or BB. Because I mean, why not, right? So I mean, we're going to use up all the alternating ones. So like if I have something that ends in an R, right, and I can just like lock it in. If I have something that ends in an R and I can just lock it in, right? It's like any singleton is a free move. That part's true. Any singleton is a free move, right? If we have RRRB, right? Or BRRB, right? Then Bob cannot touch that R. Assuming that R is going to be done before this. So like, yeah, it's a free move. Supposing we do this. Is it optimal for us to lock moves in for ourselves? Like if we have BR, right, then like we want to take, if we have BR, right, then we want to lock the red in for ourselves, which also locks it in for Bob, but that's okay. Then once we do that move, Bob would rather, this seems like it's gonna be clean, but I don't like it. I don't agree. Maybe you can write a brute force and try it. Yeah, I can write a brute force and try it, sure. But yeah, in contest you probably write a brute force for this. RB, right? Like we do this. Bob will do this and have control. Wait. How does that work? Oh, because it's odd length. RB, right? RB. We do this. So we have two potential turns here. Take away a turn for both of us. So we can take away a turn for ourselves, or we can take away a turn for both of us. Which makes more sense. So actually, yeah, it makes sense that we'd want to do RB first. The question is, how do we distribute the RBs? So actually, this is bad. Yeah, we want to be able to keep doing the RBs, don't we? BR, RB, RB. And so we have, so these are independent games. So each move is going to take away at most one R and at most one B. What we want to do is, oh, okay. Sure. So each move will take away exactly one R. We want to maximize the moves where we take away a B. And Bob wants to do the same. Sure. Sure, that works. So how does this work? So I mean each string is an independent game, pretty much. Almost. No, not entirely, but can we assume they're independent? So I mean, if I make a move on this string, Bob can make a move on the other string. But then I should have made a move on that string. RB, right? So we have length 3. We have odd length, right? How does a string like this work? So I mean, Alice wants to make it odd. Alice wants to do the last RB. Bob wants to do the last RB. So it's an even odd game. This game of freaking parody. Like, it all comes down to the wire. So Alice wants to do the last RB. Bob wants to do the last RB. Other than that, they're equivalent. So then we have this freaking pile splitting thing, right? So this is equivalent to saying this is equivalent to saying what? It's like we have, yeah, this is what it is. So how do we find these Grundy numbers then? Why are you 5e5? That's big. 5e5 is big. So if we find the alternating groups, you don't affect the Grundy number. Yeah, so so that's how this game works. And if Alice wins, if Bob wins, right, then Alice loses a turn. And if Bob doesn't win, then Alice does not lose a turn. Yeah. Okay, so this is a yes-no problem now. This is reduced to yes-no, which it already is a yes-no problem, but whatever. So, like, what is with this? Oh, what's up? Hey, remind me to make you mod, like, later. Probably not now, because that would require showing email, but yeah. It's like tonight or something. Actually, I don't know what time, whatever. Something. Alice chooses, yeah. So, in the eighth, no matter what Alice chooses, Bob can choose the other two symmetrical cells. Yeah. We're gonna have to do this, aren't we? We're gonna have to do this freaking Grundy stuff. And we're gonna have to stare at the numbers until we find something, right? That's how this works. for j is equal to 0. R dot pushback dpj xr dp. Great. This is useful. You're still zeros. Huh. Okay, so this is weird. Why are you still zeros? Why are you still zeros? That's kind of weird. I feel like I'm doing something wrong. Is there some pattern here? Is this cyclic? 4537 48112. Are you serious? How long is the pattern? 4537. 68. Are you serious? Yeah, I mean, it works. That's really dumb. You guys seeing this? You guys seeing this? Okay. Well, we're doing this. This is how you solve game theory. DPI of V is equal to DPI. If I is greater than 200, I is equal to what? Why? Oh, idiot. Okay, sure. Okay, now what we need to do is C and N This is how you solve game theory problems. This is how it's done. This is how it's done. It's so dumb. I hate this. I hate this so much. You print out the numbers, you notice a pattern, it works. (68 times 2 plus n mod 68). Okay. 4. Okay, now. If Si is not equal to Si minus D dot push back. What do you say your I minus P? P is equal to I. Okay. 2, 2. 8, 1, 2, 1. 3, yeah, okay. If V is equal to 0, minus CT. I love game theory so much. Makes me so happy to do game theory. My voice is working, right? Someone said it's not clear. Probably some resources on how can you prove greedy solutions. There's that like PDF online. I don't know much about it though. TikTok reacts, yeah, exactly. Exactly. Okay. CT is 0, C to end to S for car CS. So C is R plus CT, L minus CT. VLG, LOP is 0, S plus equals S dot back. Yeah. Cool. Cool problem. Very cool. Very cool. Very, very cool. Now we can solve the interesting ones, right? Okay. 2600? Yeah. Cool. Yeah, so basically, so we have these like strings, and in one move you can do one of the following. In one of Alice's moves, she can either remove an R, like do an RW, pretend this was white. She can do an RW and then remove a single R, or she can do an RB or BR and remove both an R and a B. In either case, the R must go, but the option is whether she can choose to remove the extra B or not. So clearly she would want to do this. She would want to remove as many Bs as possible. So Alice wants to be making RB moves as long as possible. And similarly, Bob wants to be making BR moves as long as possible. Clearly, if one exists, they'll take it. So it's just a matter of who makes the last RB move. And whoever makes the last RB move gets a 1-turn advantage. So now we need to basically solve the game of who... So we're basically solving a different game now. Who can make RB moves for as long as possible? Who's going to make the last move that's an RB? And then what we do here is we split that into a bunch of independent games. Like, for example, BRB Like, like here, for example, these two games are independent because no move can cross in between them. And any streak of alternating R's and B's is an independent game. So these are all independent games, and we need to solve them. And in one move, you can choose a B and an R and remove both of them. Turn them white. And the question is, who's going to make the last BR move? So now this is a game. This is another game where the state is the length n of the streak. And in one move, we can choose an x and split it into games of size x and m minus x minus 2. Like we can pick something and then remove it, and then now we have two independent games on the left and the right, where we have x on the left and m minus x minus 2 on the right. And so we just need to find the Grundy numbers of these games to determine who wins. And what I did was I printed the Grundy numbers, and I saw that they were cyclic. You see here, these numbers keep repeating. With a period of 68, which you just look at the numbers and see that they do that. And then once you do that, then you have the Grundy numbers. So therefore, you can solve the game. And then you just need to look through this, do the Grundy numbers. If n is big enough, just do the repeating thing. And then you just, if Bob wins, then Alice loses a turn. And then you just count who has more R's than B's. Count whether there are more R's than B's or not. That is how game theory works. It's very cool. Now let's do the interesting stuff. So 2.5 seconds and 12 seconds. A 12-second time limit. Okay, so n squared is allowed. So now I was playing a war simulator game with n towers. It's just working, right? Yeah, should be. Demonstrating easy and hard versions, the constraint on k and the time limit. Yeah, pretty much. You just brute force and then hope that they're cyclic. Turns out they are, then you're done. That's what I did, and it worked. This is why I don't like game theory, because this is not problem solving. This is just staring, hoping for a pattern. It's not fun. It's not interesting. I'm assuming the game with n towers and n bots. Count the number of different pairs of sequences A and B that we can get from all possible choices of sequence A and permutation P. Okay, Game has n rounds of attacks. In the ith round, the pi bot is still in the game. Is GF slows too? Okay. So H1 is the move. G is impossible, apparently. How many points does it have? 2250. Interesting. So K is 5,000 here. And for this one, you do less than or equal. Yeah. Nice. Two to the 18 is a divisor of m minus 1. What? What? What does that mean? What does that mean? Why? God, I feel like I have to use that, but what do you do with that? What does that mean? What does that mean? I mean, it means something. But what does that mean? The PI bot is still in the game. It begins attacking as its result. The API tower becomes occupied by the PI bot. So, if nothing attacked it, it will attack something else. Otherwise, it will not attack something else. block can occupy more than one tower. Yeah. Over all possible choices of sequence A and permutation P. It's not all unique B. It's all A-B pairs. So for some fixed A, and to count how many B's there are. For some fixed, what does this 2 to the 18 thing mean? What does it mean? Why is that useful? Why is that useful? I don't understand why that's useful. Two, 1, 1, 1, 2, 1, 2, 2. Right, so you can like what does it mean? What does that mean? What does it mean for that to be true? For array A is 2, 1. So 1 can attack first, or 2 can attack first. So A has to be a functional graph, right? So over all functional graphs, without self-reference, all right, so for a fixed functional graph, right? The answer is then for a fixed functional graph, right? Okay, for a non-cycle node, right? I can attack, or I can not attack. And I can be attacked, or I can not be attacked. Except for the endpoints, right? Anything without anything pointing to it must attack. Yeah, it must attack. So a non-cycle node with a leaf pointing to it must be one of its predecessors. Otherwise, it can be itself or its predecessors. What about the cycle nodes? Or for the cycle nodes, right? Not everything on the cycle can attack. So we're counting things over functional graphs, right? And so you must have a cycle, right? But other than that, we can choose an arbitrary functional graph and arbitrary labeling. So we get more samples with this. 12 seconds? What is 12 seconds? I'm not gonna solve this, but what is 12 seconds, man? Lead the game, it's all of its towers are occupied by other bots. Suck them around. So I mean, we almost have complete freedom, right? Like if you have a leaf pointing at you, you must become one of your children. Otherwise, you must become. Otherwise, you can become one of your children, or you can just not. You can stay yourself. As for these cycle nodes, you can become one of your children, except for you all becoming one of your children, right? You can always become one of your children, except for the case where they're all one of their children. Or except for the case where the cycle shifts, right? We cannot do a cyclic shift, but we can almost do a cyclic shift. Either it must attack or it must be attacked, right? No valid sequence A exists, or the answer is 0. Counting properties of functional graphs. I need to calculate the answer when n equals k. Can make hacks only if both versions of the problem are solved. So it's arbitrary mod, but we can do FFT, right? That's the idea. It's arbitrary mod, but we can do FFT, which is very cool. So we don't need to worry about that because that's H2. But good to know, man. Good to know. Good to know that we're allowed to do FFT. Good to know. Good to know that this problem is FFTable, I guess. I've seen this, right? We've looked at this one? Yeah. So what are we allowed to do on a functional graph? So we choose a functional graph with a cycle of some sort, right? We have to count trees of length x or size x, right? And we're counting labeled functional graphs, right? Yeah, that's weird. There's isomorphism going on here too. P1 to Pn at length then. There is indeed some isomorphism going on here, which is a pain, and we still haven't solved the functional graph part. So we have an empty cycle, right? An empty cycle of length 3. You can attack, and you'll be fine. And then you can attack, and you'll be fine. Either attack or be attacked. This doesn't seem fun. We should work it out though, because a lot of people solved it. I mean, a decent amount of people solved it. I mean, it's just it's similar to that like counting functional graph problem, but it's more complicated because you have a weird cost function. I don't understand how it works with cycles. So if we have a hanging cycle, everything will attack. Everything will either attack or be attacked. Which makes it fun. And not that cool. The answer for what? The answer for something. The answer is not that. The answer is weird. H2 actually gets solved? No. Nice. Yeah, wrong answer. Yeah, pretest 4. I get TLE on this problem. That's great. That's great. That's awesome, man. There's no way you get wrong answer. If you pass A, you pass everything. Is this nicer than I thought? It's not anywhere, but I can send it. This is pretty much it. This is my compile command. And then compar is just compile and then run the file. I don't know about this problem. Who solved this? Yeah. I really don't want to do this, so that means I should do it, but I don't want to. I don't know, man. We solved F pretty fast. You know what I mean? We solved F pretty fast. It's just like, this is so, it's functional graphs, it's isomorphisms, it's blah. So that no tower can be occupied by more than one block, but one block can occupy more than one tower during the game. Yeah. I can maybe, but should I? Should I do it? Uh, 2:15 p.m. right now. The stream is not on the main channel because I don't want to flood it with all this stuff. Because terminal works, that's why. I like having control. I don't want an IDE to screw me up. I don't want to give control of my computer to that stuff. Well, not like my computer, but like my own setup. Terminal is as raw as it gets, pretty much. Eliminate and leave the game. Buck can occupy more than one tower. Yeah. So if you have the same tree, you're identical. I think we'll come back to this one later. Maybe later today. I don't really want to do it right now. Tried this one. This one seems, this is a special round, but the D seems interesting at least. Does it have a rating? Actually, it got like no solves. Okay, never mind. Never mind. What was this one? This one I've seen. We'll come back to that one, yeah. Just something we've looked at. What about G? What is it? Oh wait, I've already looked at that. Yeah, okay. What have I not looked at? We've solved those. I'll solve this one, sure. No, the thing is, it's just like, it's just math. It's just so much math. I don't really feel like I'm equipped to do that problem, but we'll see. Let's do something more interesting. Okay, I've looked at this problem, but I haven't actually really like processed it. Given a permutation of integers from 1 to n, let's define the weight as Q1 okay. Wait, what? Oh. CSCS is good for learning things. That's it. Most of the stuff on it is, a lot of the stuff on it is not useful, but some of it is. Probably the introductory stuff is. So what would go well with 1, 2, 3, 4? So 2, 3, 4, 1 would go well with 1, 2, 3, 4, right? Because then you could have 1. No. it'd be 4, 1, 2, 3, right? 1 minus P2. You have 2 minus P, yeah. Okay, so we have that one. So P1 or Q1, right? Q1 will be compared to PQ2, and PQ1 will be compared to Q5, right? We're given an input permutation, and hard version is lex min, right? Yeah. P1 will be compared with Q5. One, 3, 4, 2. Right. Can we find some anchor index, right? Some index such that if you make Q1 1, right? Oh, we might as well make Q1 1, because it doesn't really matter. So Q1 is going to be 1. If Pi is equal to I, right, then you'll never be compared to this. Let's make Q1 1.
make Q1 1. Sure. Then whatever PQ1 is, we'll put you there. Whatever PQ1 is. Whatever P1, what am I doing? Whatever P1 is, right? Put you there. And then wherever 1 is, put you there. And if not, get as close as possible. Which direction do we get as close as possible in? One. Compare you. 2. Put 4. Yeah. But this seems arbitrary. It is in fact arbitrary. I mean, consider this process, right? We take the 1, then I want to find the location of 1. So we take the 3. We want to find the location of 3. So we take the 2. And that gives us a cycle. So trace the cycles of this permutation. And that'll give us cost 0 there. So the entire, if we have a cyclic permutation, the cost is 0 then, right? We have a cyclic, okay, right, if we have a cyclic permutation, the cost is 0, right? Because they're going to follow that cycle. If we don't have a cyclic permutation, then what? Okay, so I mean, what if we have 1, 2, 3, 1, 3, 2, 4, right? 1, 2, 0, 3, 0, 2, 1, 3. That's 4. What do we do with the cycles? So, okay, so like moving along a cycle is harmless. But what we're trying to do here is use that 4, right? So like 3, 0. And we have 0, right? Wait, that's wrong. Do 0 minus Q1, so that's 3. It's the inverse of the cycle, right? Wait, that's not. Wait, what? Okay, it's not a cycle at all. This doesn't form a cycle. It just follows the cycle. Yeah, but if we like 2, 3, 2, 3, 1, 0, right? So 2, 3, 2, 1, 3, 0. Yeah. Then we follow this cycle, right? It should still be 0. So we have 0, then your, 0, 3, 1, 2. Yeah. Okay, so if we have a cyclic permutation, the cost is 0. If we have a non-cyclic permutation, the cost is weird, right? So what we can do then is move along cycles for free, right? So we start with 0, because arbitrary. Then we can move along the cycle for free, and that makes that one free. That is, we can take the point at which 0 is. We can take the thing that points to you. Or we can go in the other direction too. Maybe we go in reverse direction. Maybe we go in reverse direction. So we start with 0. Then we go to the location of 0. It's actually the same. It's literally the same. Yeah, okay. No, then we go where P0 is. So we'll put 2. Yeah, it's literally going to be the same. So we go to 0. We go to the location of 0, right? Or we can go to the location of somewhere else. Or we can not. So we can, so like what's going on here, right? So we have 1, 2, 0, 3. So we have 0 here. Then we can go to the location of 0. Which is 2. Then we can go to the location of 2. Or we can detour, take a cycle, and then come back. Because we can go to the location of 3 instead. We can go to the location of 3, then how do we come back? Okay, this gives us a strategy. Is the answer the number of cycles? Wait. Okay. Freaking Anton, man. Okay. This is such an Anton problem. Yeah. What is going on? Okay, wait. What's the strategy here? So, we have 0. We put down 0. We go to the location of 0. That's 2, right? Then the next element is the location of 3. That's 3. We go to the location of 2. That's 1. We go to the location of 1, that's 0. That would be so Anton if the answer was 2 times the number of cycles. Is the answer 2 times the number of cycles? It kind of feels like the answer is 2 times the number of cycles. Let's find out. No, okay. Yeah, is this what we're doing? Yeah. Anton. Okay. Well, that makes sense. Guess has been confirmed. Now we need to construct it, pretty much. How do we do that? How do we do that? Okay, this problem is a lot more feasible now. So now, what we need to do is, we need to find a walk through the permutation so that every time we cross a cycle, its cost at most 1. And etc. Right, so here we start with 1, then we walk to 4. We start with 1, then we go to the location of the closest thing to 1, which is 2, so that's 4. Then we go to the location of 4, which is 2. Then we go to the location of the closest thing to 4, which is 3. Then we go to the location of the closest thing to 3, which is 5. Then we pay 0. What? Okay, wait. Yeah. No, that's weird. I mean, the assertion doesn't fail, so. Yeah. Might as well run n equals 9 too while we're waiting. So the answer is 2 for every cycle we have to cross. That's how that works. Why is it 2? That part's maybe confusing. Okay, let's suppose we're playing with a nice permutation and all the cycles are in a line, right? What would we do? We would go here, pay 1, go here, pay 1, go here. Pay 1, go here, pay 1, go here. There's got to be another way to do this. Like a way where we pay 1 per thing, right? Well, no. Yeah, because the cost could be like 8. Yeah. How's that work? Oh, Anton. Oh, Anton. Oh, shoot. What did I just do? Okay, I yanked my charger. Oh, Anton. So, what are we gonna do? How are we gonna do this? How do we construct this? Well, we could get inspiration from the brute force, but I don't really want to do that. Let's actually solve the problem. You want your permutation to be as lightweight as possible. Find any permutation. So why is n small because of the subtask? Because I mean, like, you know, that's like weird. Yeah, that works too. We jump from 5 to the location of 5, which is that. How do we walk along the permutation? Yeah, I mean this we can brute force. This is easy to check with a stress test. So once we solve it, we're good. No wrong answers on this problem, hopefully. Should be fine. Two permutations on link 2, 1, 2, and 2, 1. Wait, why does that cost 0? We put, yeah, okay, that's fine. Because it's arbitrary, yeah. We put 1 down here. We go to the location of 1, which is 2. We go back to the location of 1, which is 1. So can we do that and then like splice another cycle in between? So you can put you here, right? And can we splice another cycle in? Like if all the cycles were together, again, if all the cycles were together, how would this work? How would this work, right? Like we can go to 5, then we can go to 4, then we can go to 3, then we can go to 2. Brute force is still running. We can go to 5, we can go to 4, we can go to 3, we can go to 2. And that would give us the cost of 4. How do we construct? How do we construct? How does one construct? How does one construct? Five, four, three, two, one. All right. 5, 4, 3, 2, 1. So we do that by, we can jump to the end. Wait, how does this work? Right, so like we can, like if all the cycles are together, right? Okay. 0, 2, 1. Wait, what? Oh, 1, 2, 0. So 0, 2. Go to the location of 3. Go to the location of 5. Alright, we're doing indexing here. Yeah. Go to the location of 6. Go. Wait, what? Go to the location of 5. Go to the location of 8. Go to the location of 7. Go close to the location of 6. Go to the location of 4. Go close to the location of 3. Yeah, okay. I see. Right, it's a weird jump. So how would this work? So instead of going to the location of we start at 0. We end with a 2. When we get to 2, right? So what if, like, have 2, 0, 1. It's still 4, but now it's, so we do 0, right? We do 1, then we do 2. Go to the location of 0, which is 1. Go to location. So when we end up in 2, when we end up near the cycle's boundary, we end up at the cycle's boundary, right? We jump right. So instead of going to the location of 2, we go to the location of 3, which doesn't matter where it is. We just go to 3 instead. We have this cycle's boundary, we go to 3. Then we follow the cycle until we hit another boundary. Which in this case is 4. No, in this case is 5, 6. So if we could just like relabel the permutation or do something of that sort, but I don't think we can because the distance actually matters. But if we could relabel, we could drag them so that they're all together and then it'd be easy. But we can't really do that. Can't really do that. Cannot really do that. 0, 1, 2, right? Then we jump to the location of 3. Now we're at 5. So we jump to the location of 5 plus 1, which is 6. We jump to the location of 6, which is on a different cycle. It's like we group the cycles together. And then when we need to go to the location of 0, if 1 is on a different cycle, then we'll instead go to the location of 1. Right, then when we get to 3 eventually, how would this work here? I mean, we'd have to travel a lot, but we can't can't go on cycles like this. Like we're ensuring that this is the location of 2. How do we ensure this? How do we ensure this? How do we ensure this? So we need to 0, 1, 2. So we need to be able to do these jumps. Like if we have a cycle of length 0, or length 1, right? We can just jump over the cycle, I guess. Like we don't need to jump back on it. Right, but like how did this work with 4, 3, 6, 5, 8, 7? How did this work with this, right? This is gonna have cost 6. And so we jump to the 3, which is on index 4. And then eventually we'll come back to the 4 on index 3. Okay, let's do something more interesting. So let's do this, right? So 1, 4, 0. 3, 5, no, 6, 8. So you go to 3, you go to 6, you go to 4, no. 2, 5, 7. Okay, yes. So what's the strategy here? So we do 0. So what would my strategy be here? So we do 0. We go to the location of 0. That's 4, right? We go to the location of 4. That's 1. Then we can jump to the next guy. We go to the location of... Oh, but because we finish here... Okay, right. So that's why 200. So we can do stitching. I see. That should still be n squared, but whatever. So that's why it's 200. So can we stitch? Start with 0, go to the location of 4. Right. Then right after... So we know 1's on this cycle, we know 0's on this cycle. So right after 0, right after we hit 1, right after we place down 1 in our permutation, we jump to 2 instead. Wait. Does it also work to do... Will my strategy actually work? Cost A. So it's 0, 4,
2, right? We go to the location of 2, which is 6. We go to the location of 6, which is 3. We go to the location of 3, which is 2, but we've already done 2. Wait, no, what am I doing? 0, 4. We go to the location of 1. No, what are we doing? We go to the location of 4, which is 1. Instead of going to the location, yeah, we do 1. We go to the location of 1. We go to the location of 1, but instead of going to the location of 1, we go to the location of 2. Yeah. Okay. So we really just need to write the code in a non-horrible way. So we go to the location of 2. Then we know that the final thing on here is going to be 2. So we can then jump back to the location of 1, which is going to be at the end of this. So we just need to stitch these together, right? How do we stitch? How do we stitch? How do we stitch? So we find the traversal for each cycle. We rotate you so that you're here. There's an insert function, but I'm not going to use it because I don't know how to. I don't know its syntax. So we go to the location of 2, which is 6, right? Then 6 is here, so we can go to the location of this. Then we can go. No, but somehow we have to do this, right? So we can stitch U in here too, right? Instead of going to the location of 4, we can go to the location of 5, right? Okay, yes. Okay, I see how to do this. VL make. We need to do DSU. We're allowed the stupidest complexity of DSU possible, but we need to do it. And when we get a stitch, okay, sure, okay. We code, let's go. This is a pain, but whatever.
the location. Okay, via lock in file I equals 0 sn I plus lock pi equal to I. d.comp comp I is equal to psi. Stop. What? Okay, so what do we call stitch on? Comp marks B equals stitch comp mark A is stitch A. Okay. I don't need P anymore. 18. Nice. Let's do something simpler. 0, 1, 2, 3. Should be 6. Yeah. Okay. It doesn't matter. So it's 1, 0, 3, 2. Okay. Why? PRI psi. So we start at 0. We go to a location of 0. We start at 0. It should be lock I, right? Why? What? If T Come on. So we're starting with 0. Then we're doing 1. Then we're doing the thing where lock 0. Then right after the thing where lock this is 1. It's where lock of I is 2. Lock x is what? Lock of I is 0. Yeah. No. Still. Why? There's only one call to stitch, so. No, you should be here. What? All right. Then we want the location of 2 to be first. If bi is equal to t plus 1, p is equal to I. Global variables. Let's go. I'm out of frickin' things. Still, huh? So, what are we doing? So we go to U. No, then we go to 1. Okay. Nice. Okay, yeah, that's a bit wrong. Wait, why are you that wrong? Wait, what do you mean? Wait, what do you mean 0, 0, 0? Oh, I'm an idiot. I forgot the syntax. Okay, there we go. Cool. That is not enough printing. Oh, that's fine. Cool. Get rid of the PRs. Get rid of you, get rid of you. Cool. Okay, so now what? I don't have multi-tests, that's why. Cool. Alright, seems legit. Do we try the hard version? Hard version seems hard. Okay, so that was fun. Hard version, we need lexicographically minimal. So we need the lexicographically minimal path through the stuff so that this works. Somehow. Somehow we have to do that. How are we going to do that? Have I missed stuff in chat? I probably have. Mental blocks? Suppose you have to just try longer and realize it's not that bad, or just try until it goes away. Like eventually, like you're gonna snap out of that mindset, I suppose. Usually happens with me. Or give yourself some adrenaline or something for some reason, like solve something. Maximum size complete subgraph. That's click, right? That probably doesn't work. Yeah, this is the only one I've solved today, except for the stupid div 4, but whatever. That's not that important. Okay. Indeed. Do we try the hard version? So it didn't get that many solves, right? Oh yeah. Okay, never mind. That's a 3500. Nice. Okay, yeah, we did bad on this round, by the way, but We made up for it by upsolving D1 at least. D2 is 3,500, so that's not happening. A bunch of people tried it. A lot of wrong answers. Man, how do you solve D1 in 12 minutes? That's insane, dude. Oh, that's so crazy. Oh my god. Ugh. That's actually crazy. I don't actually like. I don't entirely understand the solution, but it works. Well, I understand it, but it's still a little bit trippy in my mind, but it works, so that's cool. Instead, we go to the location of 3, which is 3. Instead of going back to 3, we go to the location of 2. Yeah. Yeah, it's like whatever. Okay, cool. And that's the final one in div 2, right? Got like no solves, yeah. Got no solves at all. Nice. Cool. Alright. We looked at this one. Yeah, we solved that one. I don't really want to do this one. Okay. I suppose we should solve F2 from this. Where's the right A length N which I really likes? So you've changed the array to B. Memory has no array of length N. Sure likes. Today you've changed the array to B. Permutation of A, yeah. Choose two integers ij, swap bi and bj. Sadness of the array is the minimum number of operations to transform B into A. Yeah, sure. So we can't solve the minimum number of swaps. I know that's NP hard. we can do something else. IJ is 1, 4, and IJ is 2, 3. So I mean, what about like frequencies of elements, right? If it's a permutation, if it's a permutation, right? If it's, yeah, if all elements are distinct, right, then the answer is n-1. It's not the maximum swaps to swap a single array, it's the maximum over all arrays. It's the maximum over all arrays. So it's as far from you as you can get. It's as far from you as you can get. Right? So how would that work? Each test case for an AC without quotes. B has the maximum sadness. It's like, it's at least, you save at least the max frequency, right? And consider sorting the target array, right? I just consider sorting the target array. Because why not? Or rather, consider sorting by frequency, right? So the max frequency is at the end. Then if we twist the array, if we shuffle the array by that amount, works, right? Does that work? I don't remember if that works. It should work, right? If we sort the array, and we shuffle the array by that amount, okay, let's so cn to n. For I 0 is an I plus plus rai dot s equal to bi dot f. I mean, this should work, right? Because does it work? I don't know. Like, everything's rotated by at least that much. So no element is on its position, of course. And PRAB VL RN for L equals 0. RAI dot S is BI dot F. So I mean the max frequency, right? When we shuffle this, we can't really do better, right? Like if we have the max frequency, if the max frequency is small, like 2, right? We're gonna shuffle by 2. We're gonna make sure no element ends up on its place. And there's no way to like create smaller cycles, right? Well, the point is like cycles can't exist. Yeah, if there's a smaller cycle, then we're screwed, but like if there's a cycle, if we go here, then we go here, then we go here, right? And the next element is going to be over here. There are going to be at most this many cycles. Yeah, okay, this should work. So we're counting cycles, right? That's kind of what we're interested in. We're looking at the cycles of the array. This will work, right? Will it actually work? Not sure. Damn. Okay. We should write a stress test for this. Doing this for the sake of practice. Fine. I thought this was what worked. I could have sworn, but I forgot. Dist VL A VL R. Wait, what the hell? Oh my god. Okay. It's freaking stable sorting, that's why. I didn't think about that. Okay, see. God damn it. That's annoying. That's a dumb bug to, okay. That's a really dumb bug to make. Okay, cool. All right, now that we have this settled, we should use this to solve F2. That's so dumb. That's such a dumb thing to do. My God. Okay. All right. F2. F2. So we know that the max swap min ops has to do with yeah, we want the elements to be together, you idiot. God. Okay. All right. So assert ret pr ret.s and f a0.f ret.s is equal to n minus f a0.f. Why? Ret. I mean, this should be true, right? Yeah. So like we get it from the max frequency, right? So we need to see if there's a thing that breaks this array. We need to see if there's a thing that breaks. Let's run n equals 8 in like 10,000 cases, something. Why? What changed? What? Oh wait, it didn't. Oh, it never ran. Okay, I see. Why? That's why. Okay, sure. What's 5 to the 8th? 25, 625, yeah, sure. Okay, we don't need to print this anymore. So make n equals 8. Sure, yeah. So, so it's n minus the max frequency. So we need to check if this has the same sadness as n minus the max frequency. And if so, then we need to cry. That's the plan. How do we execute that plan? Still running. It's going to run forever. how do we execute that plan? Determine if B has the maximum sadness over all permutations of A. Determine if B has the maximum sadness over all permutations of A. Right, so all we need to do is find a single break, right? So let's do the same sorting. If anything's already equal, we lose. Right, like we just get that for free. If anything of the max frequency is already equal, we lose. If anything at all is already equal, we lose. But that's not enough. Like we need to be able to find a cycle. Like a cycle of smaller length than the biggest thing, right? Charge. We need to see if there's a cycle of any smaller length, right? So if any AI is equal to you, right, then we're done. Otherwise, like the swaps are gonna form cycles. So we need there to be, at most, we need there to be exactly this many cycles. Still running, cool. We need there to be exactly this many cycles. How can there be exactly this many cycles? It's like we can have a 3. You'll be here. We can have a 3. You'll be here. How do we know if there are more than that many cycles? What are the arrays that have the max distance? For auto VD. Yes, charge everything, sure. That's a lot. Okay. Christ. Okay, that is a lot of arrays. So this is fine. Wait, what? Nice. Cool. There's exactly one such array. Yeah. So, I mean, that's one cycle. Oh. Okay, so as long as the number of cycles is that. I mean, as long as the max number of cycles is that, then we're allowed to have that. What if the max number of cycles is not that? What about the max number of cycles? Well, yeah, we can't. No, we can't determine the max. We can't determine the exact number of cycles for an arbitrary array. Again, that's NP hard. NP something. NP. But we can, however, do the cycle game for this. We need to determine if the number of cycles is the same as the max frequency. Right? So the number of cycles is the same as the max frequency. So we pick an element with the max frequency. And we let's do this, because we might as well, right? number of cycles is equal to the max frequency. So for any edge on you retake it. Right. I mean, these are all equivalent. Why do you pop up, man? What is going on? Zero 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 11122, right? So 111022200. Because if we have a 2 here and a 2 here, then you'll have a 0 and you'll have a 1. And if we do, then you'll be a cycle, you'll be a cycle, you'll be a cycle, and you'll be a cycle. And that's bad. Can we focus on it relative to here? If we can it's if we can touch all elements just from here. It's if we can touch all elements just from here. But there might be a better cycle. If we can find a way to get back to you without touching all elements. I can find a way to get back to you. We can find a way to get, that's it, right? If there is a way, any way at all, to get back to you without touching all elements, then that's what's happening here. If there is a way, any way at all, to get back to you without touching all elements, that's how this works. Blah. So here, you'll go here. Here, you'll go to 2. So I have a graph with multi-edges. A graph with multi-edges, and we're playing with the cycles on it. If you have any way to get back to you, can only use each edge once. So we're looking for the shortest path. Shortest path in some sense, right? What kind of shortest path are we looking for? It's a bunch of shortest paths. It's not just one. The graph has multiple components. So, if the graph has multiple components, then we're done. The number of cycles is at least this, guaranteed. If the graph has multiple components, we're done. That's not sufficient. If any other thing has an edge to itself, we're done. If any other thing has an edge to itself, we're done. Seen that. This is long. So, I mean, no other thing can have an edge to itself. No other thing can have an edge to itself. We can visit nodes multiple times in cycles, right? But what's the point in that? Are we just like traversing the graph? Is that what we're doing? We're just traversing the graph, right? Bool check. BLA, BLR. So we don't need this at all. Turn max. Okay, so yell edge n yell vis f a I equals 0 is n I plus plus. So we draw an edge from AI to RI. Edge AI dot push back RI. Okay, now while cur dot size for lx cur vlnc. Set multi insert. If not, rx dot size turn 0. Wait, what am I doing? Edge, 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 edge x dot begin, and see back v. Problem is this could go the wrong way. If this I is not equal to fi, not actually running anything. And C is cur. Okay. Yeah, and the problem is okay. begin. Okay, so for li, for ly adjx, if not vi I dot count y, turn 0. If not f, turn 0. Adjx dot race adjx dot find y plus vis y at I is equal to y if y is not equal to m, and c dot push back I. Cool. Walker dot size. Beyond C. Li cur. Lx is add I. Blah. So what's wrong with this? So we have a 4 there, and we have a 3 there. Yeah. Well, I didn't do any of this. Vi I dot insert y. Damn. Okay, so what's wrong with this? I feel like taking arbitrary cycles should work decently, right? It's like 2, 2, 2, right? So we have 0, 2 there. Two. One sec. Okay, so what's going on here? D is 4, max is 5. So we have this cycle here. Okay, I mean, we might as well. There's no reason to not do this. Fine. Yes. So we have U. Yeah, this cycle. We have 2 to 0, 0 to 4, 4 to 2. We have 2 to 0, 0 to 3, 3 to 0. Oh. Yeah, but... Okay, PRVI. So how do we do this better? So we have 2 and 4 here. But we want redundancies. Well, we can go 0, 2, 4, or we could just go 2, 4. Right, that's the idea? We can go 0, 2, 4, or we can just go 2, 4. Wait. Wait up. Oh, no, wait, what? Ajax.erase. Ajax. How are we going to 0 twice? That makes no sense. Oh, no, it's not. Okay, wait. 1. So go to 0. Yeah. 1, which will go to 0, which will go to something else. 1, which will go to 0, which will go to 4, which will go to 2. Yeah. Or we just go to 1 and then 2. But here we do 0, and then 1 and then 2. Disregarding the fact that we can take 1 and then 2, right? Yeah, so when does that happen? It happens when we have cycles not involving you, right? Okay, so how's this work? Right, okay. Ooh. ST is equal to VLN. Dpsych I. Void dpsych. So for LX. Edge V. If X stack X psych is equal to 1, return stack X is equal to 1. Alright, if X not equal to AB. Cool. Need to make sure you're not exponential. Are you exponential? Are you exponential? You're not exponential, right? So if stack X is 1, psych is 1 return. If stack X is 0, then yeah. Okay, I have faith. Let's do this. Why? I don't need any of you. Okay, sure. Screw it. For the sake of practice, let's submit. I mean, it passes a stress test, so like, maybe. Possibly. Might fail in a large case, though. Nice. Okay, cool. Alright. Another 2800. Down. Let's go. I'm not sure why that works. Like, I'm not at all sure why that's correct, but it does pass, so that's good enough. Okay. Plan is, okay, read chat first of all. If people are still here, hi. Yes. I am not doing that contest. I'm not doing contests for a while, probably until like I'm confident enough to reach LGM. That's the idea. How's I doing rating changes? There's a bot. You go to discord.gg/ericto. Does that work? Yeah. If you go to that,
like this Discord server. Then in there is a thing called virtual contests. And then you can do this thing called rated VC that basically starts a rated virtual contest for you, and it will give you a rating pretty much. So you just do that, do the contest, and then it actually like calculates rating changes for you. It's neat. There's also a heuristic, like a mathematical heuristic given your like performance in the contest, but it's not as accurate. It's still pretty good, but it's not as accurate. It's an approximation. Okay, I don't understand why this works, like in the slightest. This problem is like beaten me before, and it's kind of beaten me again. But I mean, it worked first try. It passed stress tests. It does the cycle thing. I guess it's just correct. I mean, it just I guess it's just correct, man. I don't know what to say. I guess it's fine. I guess like I did two dumb things, and putting those two dumb things together apparently makes a smart thing, which I guess is cool. Is this solvable? It's 3200. We'll try it. 3100 probably. Yeah, okay. We'll do this problem after. Right now I want to do an AtCoder like midday, because why not? Contest. Anyway, yeah, I'm not helloing. That's not the plan. Okay. Maroon RK, great. that means okay, this one was also. Well, this one wasn't that good. The 169, I don't know. I didn't really like it, but whatever. That's fine. Okay. Where is my template? Where are you? Using yeah, okay, that's fine. Test cases. Okay. Alright, I'll be right back and we will do this contest.
All right, let's do this. Yeah. Okay. So I don't know what to expect. Yeah, I don't know what to expect. Do our best. That's the plan. I need a be right back screen, I think. I'm too lazy to make one though. We'll see. Inversion. Inversion number of a good sequence. Okay. So cool. That should work, right? Multi-tests. Cool. Simple enough. And positive stones, and the ith pile is AI stones. Just a positive integer k. Player cannot make a move on their turn, loses, and the other player wins. Damn, 6. Okay, no. That makes sense. Cool, we have 3200 per for a second. Awesome. Choose a positive integer k, and owls involved play a game with these piles as follows. Starting with owls, the players take turns. Each turn, choose a positive integer k for which there is a winning strategy for Alice. Okay, so if the XOR sum is by default non-zero, the thing is -1. If the XOR sum is 0, so we're doing mod, what is it? Mod k plus 1, right? What is it? Wait, what is it? If k is 1, the Grundy number of 1 is 1. The Grundy number of 2 is 0. Yeah. So it's mod k plus 1. Yeah. So I mean, if the game is symmetric, it will stay symmetric. If there's, okay, so if the XOR sum is 0, right? If there's an even number of the max thing, there's an odd number of the max thing, then changing it will change the XOR sum. If there's an even number of the max thing, then changing it will not change the XOR sum. So it's just, okay. C into n. Map LLF. LX equals 0. For L equals 0, S and N, I plus plus. C into Y, X equals Y, plus plus Fy. For auto VC Y. if c mod 2 is equal to 1, ants equal max ants b. If x not equal to 0, ants equal to -1. Y. F. Should be 2, right? V minus 1. Okay, right. So scene to end map LF, x is 0. So for each thing, read it in, XOR it, right? So if the XOR is non-zero, then any massive K will work. So that's fine. Otherwise, for anything, consider the odd thing, right? Consider anything with even frequency. Then changing it will change nothing. It will not change the XOR. The XOR of those guys are already 0. Anything with odd frequency, changing it will change it. So doing that works. So, yes, okay. I have faith. I submitted twice. No, I didn't. Okay, good. Glad that didn't happen. You're given a string n is of length n between 0 and k times inclusive. Freely choose 2 characters in S and swap them. Okay. Freely choose 2 characters in S and swap them. Okay, we're pretty fast, eh? Pretty fast. Good. You're given a string S, yes. Okay. You have a large sample, right? Thank you. Okay, well, we just played a game with swaps. We just played a game with swaps. So we can sort the string. So really it's about, yeah, we can sort the string. So really it's about frequencies, which I guess is a thing. Really, it is about frequencies. So what's with k equals 100? So we have the A zone, the B zone, and the C zone, right? Ow. We have the A zone, the B zone, and the C zone. And what we can do is swap 2 things. So we can count wait. We can count A's in B, A's in C, right? And that tells us, you can count A's in B and A's in C, and that tells us the number of, what does it do? It tells us the number of, yeah, so k is 100. Okay, so the n barely matters. So we can count A's and B, A's and C, yeah. We have big modulo. 998244353. Okay, so we can count A's and B, A's and C. Right, and then B's and C. And that information tells us the number of C's that are in C. We know how many A's are in B. We don't know how many B's are in A, do we? Is that enough? Or do we need 4? Do we need 4? I mean, we can have 4, right? Yeah, we can have A's in B and C, and B's in A and C. Wait. What? No, yes. And because we know the total number of A's, that tells us the number of A's in A, it tells us the number of B's in B. And we know the number of C's in C. We know the number of, yeah, okay. Sure. Okay. So, wait, but, oh, well, that's problematic. Wait. Okay, we need to, like, uniquely determine this, right? Because that's the number of ways to do it after this many swaps. So we need to, like, A, B, and C, right? So we can have the number of A's in B and the number of A's in C. And that tells us the number of A's everywhere. So now at this point, we know we have a certain number of B's and C's. We know how many non-A we have everywhere. But the C's could be spread out and the B's could be spread out. We know how many non-A's we have everywhere, right? We know how many non-A's we have everywhere. But it's end of the fifth. Okay, it's end of the fifth. We need to not be end of the fifth, right? We know. What do we know? Wait. Oh, yeah, okay, wait, no, okay. We don't need number of ways, I'm being high. We only need the number of strings. Given that, we can iterate, in fact, yeah. Given that, we can iterate and do min swaps and see if it's reachable. Yeah, we don't need to do this stupid DP thing, I'm thinking. We can iterate and do min swaps. Alright, so iterate and do min swaps. So for C's and A, we'll swap C's directly. For B's and A, we'll swap B's directly. So for A's and A, we don't cost. So what do we need to do? So we have a certain number of C's we have in A. We have a certain number of C's we have in B. We have a certain number of C's we have in A, and we have a certain number of C's we have in B. So we can do those swaps directly, right? Like, why not? So we have A's in B and A's in C. You know, initially... Oh, right, okay, yeah, right. So we want the counts to be something specific. So we're initially going to swap as many ABs as possible. Then we're initially going to swap as many BCs as possible. Or swap as many ABs as possible until we run out of A's. Now say we need more A's to be in B. We're out of B's. Then we need to swap through a C, right? So we do as many ABs as possible. We do as many direct ACs as possible. We do as many direct BCs as possible. This is a pain. This is a very big pain. We can do it though. Then to get an AC, to get an AB, we don't need any more B's in A, but we need more A's in B. And these B's must go somewhere. These B's must go to C. So we need some BCs. Okay, I see. Yes. Okay, so ants equal to 0. BLC. For LO AB is 0. Wait, no, okay. Let's do it the other way. Well, BA is 0. BA is less than or equal to lim1, and BA is less than or equal to lim0, BA plus plus. CA is 0. CA is less than or equal to lim2, and BA plus CA is less than or equal to lim0. For AB is 0. Is less than or equal to lim0. AB is less than or equal to lim1. CB is 0. CB is less than or equal to lim. CB plus CA is less than or equal to lim2. And BA. What is it? So it's AB plus CB is less than or equal to lim1. Okay. now CV00 is equal to CT0. So bring A's. Wait, what are we trying to do? We're trying to do swaps. We're trying to do swaps, right? We're trying to bring A's into 0. We're trying to bring A's into 0. So trying to swap AB in location 1. We're trying to swap. So it's 0, 1, AB. Okay. Swap. Wait, I plus 1. CT0 minus BA minus CA. There's got to be a better way to do this. CT1 minus AV minus CV. Targ 1, 2 is equal to CV. So it's CV I CV JL minus targ JL CV targ IL minus CV IL targ JK minus CV JK. And CK. So it's CT0 targ CTT targ T 0 mod times NCK CTT damn. Okay. Cool. Why? Yeah. Does this work? No. Why are you negative? you broken? CV is 1, 0, 0, 1, 0, 0, negative 1, 1, 1. Why are you negative? Okay, thank you. CV and targ, right? Target's now, wait, what? Yeah, target's negative, that's why. Wait, what's negative? Something's wrong with the math here. Yeah. Okay, see, that's valid. CT J. Still. Oh, you wouldn't work anyway? Yeah, okay, that's fine. So we're allowed to do one swap. We're allowed to do one swap. We're counting this again. No, it's CT is always that. Wait, what? Okay, wait, this is fine. Okay, I'm glad this doesn't work because this is a pain. So we need to move the A's out. Let's just do this better, right? Let's move the A's out. So we have a certain number of A's that need to be in B and a certain number of A's that need to be in C. We know that it works. And my God, what the hell is going on? A certain number of A's that need to be in B. Okay, this is stupid. Let's not. Let's get rid of this. This isn't going to work. Targ. So the number of do the same for 2. Okay, right? Now, how does this work? I've solved this problem before. I don't remember how to do it. God, I actually cannot think this through. What is going on? Cannot think this through at all. Like, we want to move you into here. Want to move you into here. We have A's, B's, and C's. We need to move A's into the B's and B's into the C's, right? Now, like, what does this mean? What does it mean to do this, right? If we're going to move a B into a C, like we have a certain number of C's in A, and a certain number of B's in A, right? And the sum of them must be equal to the number of A's in B and the number of A's in C, like by definition. So one of them is going, like, say we need two A's in both B and C. We need 3 C's in A and 1 in B, right? So we're allowed to do this. And we're allowed to do this. Then what we need to do is move so we need 1 left, but we have none. And we need 1 left here. Okay, now LD abs targ 01 minus CV01. R plus equals 2 times D. Then targ 1, 2. 5. Great. Y. So we need an A and B. Wait, what? This is the other type, isn't it? So we need an A and B, an A and C, and a B and C. So we need an A and B, an A and C, and B and C. And a C and A. All right. Let's see. Let's see. Okay. Damn. Great. Oh. Okay. So why? That's big. R is 1, 0. PRR. Okay. Okay. Jesus Christ. That sucked. And that was horribly slow, I imagine. Okay, see how fast you are. Okay, that's fine. Yeah, okay, sure. God damn, man. That's so annoying. Okay. Pass. Thank you. Jesus. How slow is that? Yeah, it's not the best. Okay, come on, we can say this. There are n squares arranged in a row numbered 1 to n from left to right. Initially, all squares are white. Perform the following m types of operations any number of times in any order. Okay, that was fun. That is definitely not the best way to do that. I mean, Jesus. N squares arranged in a row number 1 to n from left to right. I mean, we kind of have to do that, though. Paint square Li through square Ri in black. Find the maximum number of times the operation can change the state of the squares. Okay. An operation changes the color of at least one square. That operation is considered to change the state of the squares. N is up to 500. M is up to n choose 2. Sure. Can we do range DP or something like that? It's n cubed. N cubed is allowed. Four, 3, 1, 2, 3, 4, 1, 4. Perform the operations as follows. I'll change. Okay. Alright, we're doing this. Seems fun. So I mean, start from the beginning, right? Like, suppose we decide to take an interval up until here. Suppose in the very beginning we decide to take an interval up until r. We keep track of r. Now suppose in the next position no, it's not just an interval. Like we can take multiple intervals. The smallest of which will be applied first. Where we apply them, yeah, or size. We move on to the next one. We move on to the next one. Where we can then decide to take another interval or not. You can decide to take an interval or not, right? You can decide. No, we're going to take a prefix of the intervals. Okay, yeah. I'm going to take a prefix, not just any arbitrary subset. Well, no, maybe it's blocked out. Yeah, it could be blocked out. Like this, then this, then this, then that. If we're going to do this, we'd rather do this. So if we decide we're going to take this interval from the very beginning, right? So if we leave this one uncovered, right, then that means, so if we don't take anything else from here, that means we just get this for free. We can do you after all of these. if we do get you from the very beginning, and if we don't, then we must get you from over here. So you're essentially reduced to this interval. If we don't take this, yeah. I have a zany idea. I have a zany idea. Let me think this through. So we have at most one interval starting at each point. So if we have multiple, just don't. Okay. Okay, this is insane. Does this work? This is n squared. Hang on. There's no way this. Hang on. This feels sus. Why did not terminate? What do you mean? Oh, M. This is a zany idea. Wait, what? When do you get more? There's nothing starting at 5. One, 1, 1, 2. So you get pushed to 3, 4. You get pushed to 3, 5. So do you, right? You get pushed to 3, 4. You get pushed to 3, 5. Yeah, wait, that doesn't keep. Okay, what am I doing? It doesn't yet work, but it might work. It means they're not compatible, but what does it mean? There's something here, though. There's absolutely something here. This is just not it yet. Right, so you might cover you, right? We're assuming we're taking this, though. And if we're assuming we're taking this, then we can assume that this interval doesn't hurt to take. But that assumes that we take this before this. And we move on to the next set of intervals. Let's say we have that, for example, right? Then we have this. I'm assuming we're taking this. Then we have this. Then this goes out. I'm assuming we're taking this, then we have this, then we have this. Both of these are here. Are you 800? Yeah. Okay, we don't need to do this yet. We need to. We take these intervals, and you are going here. So you could push past here, but we could instead do this. So we had this, right? Yeah, we need ordering. We need ordering here. You could push past here. You could push past here. We're assuming we're taking this before taking this. Right, so then you become a special interval where we're only allowed to take you if there's some spot over here. And for the rest of the intervals, what does it mean? we're building up some stuff so that we can take them from the back, right? So we'll do all the regular intervals. We're building up some stuff so we can take them from the back. But do we want to take from the back? Like, what if we didn't, right? If we're assuming we're taking this interval, this interval almost becomes here, but it doesn't exactly. It doesn't exactly. It becomes here in its requirement, but not in its covering. So if we have a thing with smaller requirement, then we'd rather take that, regardless. We have a thing with smaller covering. Yeah, if we, no, it's the other way. If we have a thing with smaller covering, then we'd rather take that regardless. But then we could still try to take this. Out of curiosity, you don't pass this one, right? You shouldn't pass that one. Okay, good. If it passes the large sample, that's concerning. So we want to move you. Wait, what am I doing? Okay, think. So each interval has a min requirement. So like if we have something like this and then this, right? If we take this and we don't take either of these, then this is fully covered. Which means that there's no point in taking this. Which means that we should have taken this. Which means that we should have not taken this. So actually this is the one to take over this. We would prioritize taking this over this. So then this would become such an interval. take this. And we take this. And we should have taken this instead. We're assuming this is going to be covered. We're assuming this is going to be covered because we have an interval that covers it. Wait. Oh, we don't need to do any of this. Oh my god. We don't need to do any of this, do we? No, we just do the frickin' thing. We just do the frickin' thing, dude. We don't need to do any of this. We don't need to do any of this frickin' analysis. Oh my god. Wait up, hang on. Does this actually work? Consider the final thing we take, right? Consider the final uncovered cell. Considering the final uncovered cell, all we need to do is say that that cell is guaranteed to exist. Which means that no intervals cover this cell, which means that we're fine. How much memory do we get? Okay, that's fine. Okay, we don't need to do freaking any of this. We don't need to do any of this. Why are we analyzing this so hard? Well, we need to be a bit smart about how we do this, but... No, we don't. We do not, right? Okay, so we just need to efficiently tell, is there an interval on this range that covers you? Let's iterate over L and R. Let's iterate over L backwards and iterate over R, right? Okay, we just need to do a bit of book work. Why? Why am I so annoying? Why do I do this? Okay, come on. So how do we do this efficiently? And we get a new R, right? We just we just go through all the intervals. Okay, that's fine. All right. Okay, for L is equal to n minus 1, L is greater than or equal to 0. Plus PS L X minus minus. Yeah, that's fine. For L K is equal to L, K is less than or K plus plus. T plus equals PSK. dp L K minus 1 plus dp K plus 1 R. That's it. I don't know, man. Yeah. Okay. I'm an idiot. Seem to NM. Seem to LR. I've solved a problem like this before. I don't understand why it took me so long to see that idea. But whatever. Yeah, and like... Make sure it still works. Yeah. L is not equal to K, dp L K minus 1, 0, plus R is not equal to K. Yeah. That really should not have been like that. Okay, so C took longer than D, unless this gets wrong, but hopefully not. Good. Oh, Coroni, nice. Nice. Yeah, that was sad. This was very sad. This whole contest is very sad. I don't know what to say about it. Why am I resigned to this? Okay, I mean we still have some time, right? Yeah, 30 minutes. Okay. See if we can do this, I guess. Given a sequence of positive integers. It's going to divide this sequence. Number of ones whose sum of elements is at least S. Well, that's similar to the previous one. But it's not the previous one. Something's different about it, evidently. Oh, so K subsequences. I see the issue.
So I mean, consider the amount of subsequences we're allowed. What? Oh, well, yeah.
So I mean, yeah, if there are less than k possible ones, then just merge. That's fine. You know, if there are more than k possible ones, then merge. If there are at least k, yeah. So we're gonna have single elements and we're gonna have subsequences, right? Now what are we gonna do with the single elements? What are we going to do with the single elements? So large sample seems useless, which is great. That's cool. So we're gonna have, so if the answer is at least k, print it. Otherwise the answer is less than k. So the question is, how many do we get? So I mean, we take one or we don't. Yeah. Cool. NKS A1 to AN. Yeah. Consider an attempt to do this, right? If we run out of sequences, then got some big guys and then some ones. That's like mainly the case that we're thinking about, right? A lot of ones. Ten, 5, 3, 1. Do we process and we get more than K? Like sample 1 is really the only interesting sample, and it's so small. It's a shame. What if we took the gradient and used it, right? Because like we know from the greedy solution that this is the maximum number of things this can be partitioned into. We took the gradient and used that because this is the maximum number of things this can be partitioned into, right? What does it mean? And why? Is the maximum number of things this can be partitioned into. We might want to move elements. Gradient in the reverse direction, maybe. That help? And we'll find a segment of useless. Like we want to interfere as little as possible with the good ones. Somehow. And we know the answer is at most some big number. Tell me about like 20. K non-empty contiguous subsequences. Among these K contiguous subsequences, the number of ones whose sum of elements is at least S will be called the score. Find the maximum value of the score. Number of ones whose sum of elements is at least S will be called the score. Find the maximum value of the score. I mean, we do know that, like, this is at most this. If we have a useless segment here, like, take the gradient and adjust it, maybe? Take the gradient and adjust it. Like, consider the rightmost interval, right? What will you be best? Consider the rightmost interval. What will you be best? We move you to be as far as possible. Say I have a big element right here. And I'd rather take you than any of these. I know I'm gonna take you What if like it's like the most elements it takes, the fewest elements to reach this many? So what's going on? I mean, like, no. What will be going on? this doesn't work. All this does not work. Man, why am I so bad at AtCoder? I don't understand. It's much worse at AtCoder than the other thing. I mean, we could... I may not want to do any of these intervals until here. We do a binary search, and suddenly all we need to do is find a single quantity. Which may be easier, but I don't know. We have a list of intervals. We need to select k disjoint, m disjoint ones of minimum length. The intervals are strangely shaped. They're all, none contains the other. Given that what? I mean, we don't have enough time now, but given that what? Okay, well, I guess it's done. That's a shame. He solves it again. Nah, yeah. That's about right. I don't know, I just don't do well with AtCoder. I don't know what to say. Need to get better. Oh, this sucked. Yeah, C was awful. And we could have absolutely done it better. If we just, yeah, done it better. We just done it better. Like if we just not done what happened in this code. I mean, we could have done this quickly. It's just tricky. Should we have done this quicker and for something simpler? And no solves on F, of course. Because why not? Freaking LGM's doing it. Can't solve F, imagine.
Maybe with more time, but did not have that much time. Okay, well, let's go back to CF, I guess. Okay. Yeah, either way, you crushed me. Good job. Amazing. 3,200. Yeah. That was solid. I don't know. I need to... I'm not prioritizing AtCoder. I just need it for contest practice, but I guess I should get better at the problem style. This looks strange, though. Oh, that's weird. I don't have 2,800 powers anywhere except Codeforces. Doesn't really make sense. Probably I'm psyching myself out. I don't know.
Okay, so what's with this? What can we do with operations, I guess? So I mean, if we do operations in a square, right? Okay, so we can fill a 4x4 square. That's weird. If we do operations on a rectangle, similarly we can fill any rectangle like that. Alright. Should be able to. N equals 1 looks like a pain. I guess it comes part of the package. Yeah, so you can fill an arbitrary square. Or an arbitrary rectangle. Well, not an arbitrary rectangle, but like, yeah. Okay, so if n is greater than m, we transpose. How about that? Then either we have 1 row or 2 rows. So given 4 operations, right? I obviously 2 operations in the same cell cancel. We have big constraints. So we need to be able to characterize these grids pretty well. Yeah, I mean, we need linear, pretty much. mean, top left, right? No, I mean, that's not enough. So, I mean, yeah, if we do 4 ops in a rectangle, it does exactly that. Does that give us anything? I mean, not really, right? So given that, what can we do? So the parity of the grid size is important, isn't it? And suppose n is 3, right? And we fill in our rectangle. Suppose n is 3. We fill in a rectangle. I'm going to do something to it, right? Give ourselves this L shape. I mean, there's parity. There's definitely some parity going on here. Like if n plus m is odd, then no. Yeah, if n plus m is odd, and I flip an even number of cells each time. So just guarantee you can't do better than that. I mean, there are a lot of possible grids, like, that's for sure. Well, if any of them are odd, we can fill an entire row except for us with 2 operations. And no, like 2 rows except for us. Which still fills an even number of cells if any of them are odd. If one of them is odd. And this still the weird. Why is my chat not loading? And there's still the weirdness of doing a single operation or sporadic operations. That's all weird. Yeah. Okay, so how do we reduce a grid to 0? Think about it that way. How do we reduce a grid to 0? What can we do? Well, we can do the rectangle thing. So any two guys in the same row or column, we can drag them anywhere in that row, in that other thing. For example, that's one thing we can do. But those are just the operations up to 4, right? Those are just the operations up till, like, 4 operations at once, which is not necessary. Given oh yeah, I've not been doing that at all. True. That wasn't even the right AtCoder link. Nice. Very nice. Yeah, I'm going to need reminders for that until I get in the habit of it. Sorry. Blah. I mean, it's definitely exponential. Like, there's no small answer stuff going on here. Further, if n is if there are an even number of rows, we can flip an arbitrary 2 cells in the same row. If there are an even number of columns, we can flip an arbitrary 2 cells in the same column. If both are even, we can flip an arbitrary pair of cells. Therefore, both are even, we can flip an arbitrary pair of cells. And if both are even, we can wait, okay, hang on. Stuff is going on here. Yeah, if both are even, we can flip an arbitrary pair of cells, right? Because we can, like, what can we do? Well, one operation will flip an odd number of cells. Yeah. One operation will flip an odd number of cells. And we can pair undo the ones that aren't odd. Yeah. So if both are even, we can flip any cell. Okay, that's a fourth of the problem solved. And I guess it's the easier part. That's a shame. So both R and C are even. The answer is 2 to the K. That gives us something. That's true, right? Because, like, you know. Yeah. I'm flipping an arbitrary pair of cells because we can do the thing. So we do the thing, and that gives us an odd number of cells flipped. And we can flip an arbitrary rectangle to flip an arbitrary set of cells in the same row and column. And then use that to flip an arbitrary pair of cells, and then do a single flip on the cell we want, and then delete, and then pair delete the other ones. Yeah. Yeah. Okay. Good. Now, what else? What can we do for the rest? Let's say n is odd, m is even, right? Say odd rows, even columns. So we can still flip odd rows, even columns. So we can still flip an arbitrary pair of cells in the same column by doing the thing. What does that give us? What does it give us? We don't have much freedom when both are odd. Let's take some notes, shall we? I might actually keep that. Yeah. Let's not forget that. Okay. Given other things, what? Given 1 even, 1 odd. we'll always have an even number of cells. Okay, given even, so odd rows, even columns, we can flip any row arbitrarily because we can cancel out the column that was flipped. We can flip any row arbitrarily. What does that give us? What does it give us? We can flip an arbitrary 2 in the same column, or we can flip an arbitrary row. What else does it give us? So we know we have an even number of columns. What else does that do for us? No, that doesn't work. Well, I mean, we know we're going to flip an even number of cells every time. That's guaranteed, because m plus m is odd. Therefore, n plus m minus 1 is even. So we can't go down to arbitrary cell. And we definitely can't with odd. But what can we do? Is that really what this problem boils down to? Odd n, even m. Flip arbitrary 2 in the same column, arbitrary row. Is there anything else we can do? Like, what else does that give us? Like, that is equivalent to an operation. Yeah, those two are necessary and sufficient. Which means that we can flip each row arbitrarily. And then for each column, actually, we only ever need to flip a row once, right? Because then for each column, we can flip 2 guys. So we flip a row once. Then in each column, we need an even number. Or in each column, we have an odd number. That's necessary and sufficient to knock it down to 0. Right? Sample checks out. Sample checks out, eh? So 1, 1. How are there? Wait, what? Wait. Wait, what have I done? Oh, this is the I'm a high. That's what I'm doing. Yeah, okay. Yeah. Perfect. Okay. Sample checks out. Good. Okay, so odd n, even n m. Okay, so 2 out of 3 cases are taken care of. That's good. Now we need to handle the final one, which I assume is the hardest one, because why not? Actually, it's just It's always 2 to the number of question marks minus 1. Or 0. Which is interesting. So that's easy. And of course, even is even easier. I said even. Nice. I'm in shape. Is my chat updating? I don't understand. Okay. Yeah. Yes. Okay. So 2 out of 3 cases are handled. Now we go for the hard one. So odd n and odd m. What can we do? Okay, let's think of something, right? We can do weird things. This might be where we brute force. Because, like, why not, right? So we need to find necessary and sufficient. Currently we have one direction that we can always flip an arbitrary rectangle, but that's not enough. That doesn't. I mean, we can flip an arbitrary rectangle, but that doesn't give us anything. We still have the cross that's unchecked for, unaccounted for. It's like, what does this mean? Still have this thing that's unaccounted for. So if we do 2 operations, right? If we do 2 operations, we get a weird thing. Like this is So 1 1 is probably an edge case, I guess, and then odd. Yeah, I don't know. That's fun. Odd, right? So I mean, we've reduced the problem to 1/4 of the cases, technically 1/3 if you look at it that way, but only 1/4 of possible inputs can stop us now. Technically less. This is stupid. So what does that mean? Technically less, yeah. My God. What's the portion of inputs that can stop us now? Like if it's 2 to the k, then we have 2 to the k plus 1, 2 to the k plus 1. Okay, so it's 1/9 of the inputs that can stop us now, but that's still a lot. That's still like, you know, that's still a number that can't be represented in a computer. Well, no, it can, but it's like 2 to the, yeah, it's a lot. I don't know why I'm doing this, but yeah. No, it's 3 to that. Okay, yeah, that's true. So there's actually even fewer inputs that could stop us now. But this is all stupid, so. If anyone's watching this back, if I watch this back, I'll be like just in delirium. I won't even know what I'm talking about. It's crazy. So, like, what? We need to characterize our operation somehow. So what else can we do, right? We can flip 3 cells, right? That's what I was thinking. Like we do 2 operations. All right, and that means we need to flip 3s. Do we really need to edge case the rows? Like, that'd be so annoying if we had to do that. Can we like not have to do that, please? Please? Thank you, please. Ah, this is so dumb. So actually, wait, this would be, yeah. This would be kind of a pain, wouldn't it? No, well, no, all could be odd. No, it works. It's fine. It's fine. All could be odd. All could be even. That's fine. Yeah, that's fine. That's fine. It's 2 times. No. No, just don't be an idiot. Just do it, man. Just don't be an idiot. Okay. Oh. This is gonna work. We have a plan. We have to figure out odd. That's the troubling part. I mean, the fact that it's odd is like somewhat helpful. So I mean, we could do a row column and then do another row column, right? And then that's not helpful. That's not helpful in the slightest. Do that and then do that, and then it's as if we did the operations there, which is not useful. Yeah, because it counteracts. So, okay, but what was I had something in mind and I lost it, and now I'm sad that I lost it because I feel like it could have gone somewhere. So we do 3 operations on a 3x3 grid, right? In a diagonal. Yeah. Well, if you do 2 operations, right? And we have odd. Yeah, that doesn't help. 2 operations on the same row, right? What it will do is it will eliminate everything on that row. And it will be equivalent to doing a bunch of rectangles, which is not useful. We need something else that's not equivalent to rectangles. Anything that's not equivalent to rectangles, pretty much. Just something that's not equivalent to rectangles, man. That's the hard part. Blah. I mean, what can we do? Like in a 3x3 grid, we could do this weird like triangle thing. Not triangle, but thing. I mean, that's not useful. What is useful? What's useful about this operation? The first sample is the weird one. It's really weird. It's really weird. We need like more first samples. If we fail, we'll write a brute force, I guess, because why the hell not? Should be fine. Why the hell not? Flip an arbitrary 2 in this row. Yeah. Need an equivalence. We need an equivalence. And it's weird because, I mean, the first sample is weird. Somehow we need to, Okay, in the first sample we can fill up the whole grid. Does that mean anything? In 3x3 we can do so much. In 3x3 we can fill up the whole grid. Which doesn't actually give us that much. Which does not actually give us that much. So I mean, we can do this. Wait. No, that can't help, right? But will it? But will it? So if we have a 3x3, if one of them is at least 3, right? Now both of them are at least 3. Otherwise, one of them's 1, and that's stupid. So both of them are at least 3. We can do the thing. We can do the thing. What thing? So this and this together, this and this cancel. Yeah. Then we can do this. Wait. This and this together. This really would have been faster with a brute force, honestly. Ugh. No. This gives us nothing, doesn't it? No, it gives us an even number of flips, yeah. Shame. Are we really constrained to mod 4? It might just be. Constrained to mod 4. And what does arbitrary rectangle give us? We can use it to reconstruct the flip, right? Can we? Wait. Can we use arbitrary rectangle to reconstruct the flip somehow? I mean, fundamentally no, because it's going to give us an odd number of... If we have 3 and 3, a flip will do 5, a rectangle will do 4. So fundamentally we can't, simply cannot have that work in our favor. blah. Okay, in 1 by 1 we can flip a cell. In 1 by x we can flip a row. And that's all that works. So in 1 by x we can flip the entire thing. So if all are the same, what can we do with 3 by 3? Should we write a brute force? Let's not. Let's not. For the sake of practice, let's not. In contest, I would absolutely write a brute force because it's stupid. But for the sake of practice, let's derive this construction. What can we do? Is there much we can do? There might not be. I mean, it might just be complicated. I mean, what can we do with a flip and an arbitrary rectangle, right? So flipping an arbitrary rectangle gives us an arbitrary rectangle. We can flip like the entire diagonal. Does that give us something? Maybe that does. Wait. Can we flip an arbitrary diagonal? Yeah, we can. Can't we? If we do flips diagonally, it'll give us something weird. No, but that's not useful, is it? Because that's equivalent to flipping rectangles. We do an even diagonal, right? What does that give us? We do an even diagonal. Gives us a... What? If we do an even diagonal, it gives us a triangle shape. It gives us a triangle shape. What? No, but that also comes from, damn. Okay, that was actually almost promising. But now it comes from flips, rectangles. We need something that doesn't come from rectangles. Just absolutely need it. We need it. Problem is right? Yeah. We need something that doesn't just flip rectangles. Something that doesn't just flip rectangles. We need another observation, don't we? Something of this sort. I mean, we're given an operation, we need to find out what we can do with it. That's the task at hand. Wait. No. What? Wait. Do this. Do this. Flip. No. Okay, that doesn't work. Damn. Nope. Same as that. Well, it gives us this weird, Oh, no. Wait. Oh, no. I have a fear. have a fear. So if we create a triple thingy, and we do another one, wait. Oh, no, wait. So if we have 5 by 5, this problem is so weird. So if we have 5 by 5, right? If we have 5 by 5, we can do that. This. No, that doesn't necessarily. No, it doesn't. No. It gives us that with that as an extension, right? Which we can then move around. This lets us move around our operations, right? What if we, like, I don't know, like if we do one operation, right? Then what does the rectangles give us? Like we can do with one flip, without a flip. Can we simulate 2 flips? So a rectangle is 4 flips. Can we simulate 2 flips with just the rectangles? If so, then all we need is to toggle between one flip and no flips. Can we simulate 2 flips? Right? So we can do the thing. We can simulate 2 adjacent flips. Can we simulate any 2 flips? We can simulate 2 flips on the same row or column. Which, wait, we can, right? We can simulate the effect of 2 flips on any row or column, right? Because we can do that. We're allowed to do that. We can simulate the effect of 2 flips on any row or column, which means we can simulate the effect of any 2 flips, because flips cancel. Right? Am I mad? I don't think I'm mad. I think I'm fine. Can simulate the effect of any 2 flips. Can simulate the effect of any 2 flips. God, man, God. Why? Okay, wait. Right? So we do this. 2 flips here. The row parts are going to completely cancel. The column parts are going to be this. So that gives us 2 flips, right? Then, if we want to do this, we do this so that you stay, you get bonked, you stay, and therefore you stay bonked, and you get unbonked. Yeah. Okay. Okay. Therefore, any 2 flips can be simulated with the rectangles. Any 1 flip can be dragged around anywhere else with the rectangles. Therefore, all we need is, do we do a flip or not? All we need is, do we do a flip or not? Which doesn't affect our question marks, but it affects this. And then we just need to see whether we can drag the grid to 0 with the rectangles. So what does it mean to be able to drag the grid to 0 with the rectangles? Well, does it mean the XOR of the columns has to be 0? Or like XOR the rows together and they have to be 0? Is that what that means? That is what that means, right? Is that what that means? That can't be what that means. Is that what that means? Wait. The XOR of the columns has to be 0. No, well, okay. Like to flip this, right? We'll just flip this one. And then you'll be this XOR this. And then to flip, yeah. Yeah. XOR of columns or XOR of rows, right? Or both. Wait, what? Wait. Well, how does that work? Wait. It must be both, right? Yeah, like if we have an odd number of things on any column, we're done. If we have an odd number of things on any row, we're done. If we have an odd number of things on any column, we're done. If we have an odd number of things on any row, we're done. Or what else? So let's say we need even on every column, even on every row, right? And the XOR of the column, the XOR of the rows has to be 0. Which means even on every column. So it's even on both. It's even on both. That's hard. That's kind of hard. That's the task. That's the task we're given. How many configurations are there so that we have an even number of ones on each row and column? That's not a quote. Wait. How does that work with... How does that work? Because we can do one flip here, right? How does this check out with the rest of it? We can do one flip here. Even on every row and every column. How does that work? How does it work? I mean, how does it work? How does it work? Okay, wait. Given the other operations, right? Given the first two operations, I mean, given operations on even, right? If we do a flip, why is this more lax? Because two flips. Oh, right, because it's not true. That's why, because it's not true. Because one does not simulate two flips here. It simulates something else. Okay, yes, okay. Okay. I see. So it's not equivalent. So okay, we're almost done. We're almost done. We're almost through. We just need to do the combinatorics part, I guess, right? Starting from the grid filled with 0. Well, this is an equivalent. This is equivalent. This is equivalent. Right? It's necessary. It's necessary and sufficient. It's necessary because if we don't have even on each row and column, then we can't, I mean, all we can do is drag these two to meet each other. If we don't have even on each row, we simply can't do better. If we don't have even on each column, we simply can't do better. If we do have even on each row and each column, that would be invariant. Okay, well, we can simplify the input. If we don't have even on each row and each column, well, if we do have even on each row and each column, we need to show it's sufficient, right? So we bring you down. And we continue doing so until we're out of rows, right? And because of the way this works, everything will be dragged to you. Because we have even, we'll always have even on every part. So yeah, you'll be dragged. Okay. Okay, so what we need to do now is simplify our input. All right, so what we're going to do is drag everything down to the bottom row. So if we have so for the first row, if we have an even number of ones on it, great. Drag them all down. If we have an odd number of ones and no question mark, the answer is 0. Otherwise, pick one question mark, add it in, and drag that down. Do that until all of the rows are complete, except for the last one. Now everything has been reduced to 0 except for the question marks and the ones on the bottom. Now at this point, there's not much we can do, right? Well, what do we do with this now? We go column by column. I mean, suppose it was all question marks, right? Okay, we can find equivalent formulation. All we need to do is find equivalent formulation to even on each row and column. Because that's unsolvable by itself, probably. So what's equivalent to it? Well, we can mess with the input, but that... So all things are now 1 or 0. How many grids? If all are question marks, right? How many like grids are there? A lot, right? Many. But like how many? What can we do to our input? We could swap rows and columns arbitrarily, right? So we can move all the ones together. Sure. Like, why not, right? We can move all the ones together. So that doesn't affect the condition. Then what? What does it do? What does it do? What do you do? Count the number of ways to fill in a grid with question marks so that there's an even number of ones on every row and every column. That's what we need to do. That's our task. That is our final task. That is all we have left. That is all we have left. How? That's the question, right? How? Two of the k ways of filling up each grid. Why do they specify finite number of times? It's kind of weird. So if we have odd in 2 columns, right? Even if they're like perfectly lined up, I'll never get rid of it. I'll never be able to get rid of it. Because maybe 2 flips will flip an even number of cells. Can't really change parity like that. Every 2 flips will flip an even number of cells on each row and column. Now, yes. How? This feels NP hard or something. NP something. This feels not possible. And yet this is the problem we're tasked with solving. Somehow. So you must be 0. You must be 1. Wait, no. You must be 1. You must be 1. Wait, what? Oh, yeah. Then you're 1. Then you must be 1. Yeah. Okay. So what's up with that? I'm actually lost. This is hard. Yeah, so We can't just XOR them together. We cannot just XOR the rows together. We simplify the input as much as we can, which is kind of a cute thing to do, but like, what does it leave? What remains? When did I graduate? 2025 spring. That took me a while for some reason. I'm tired. We're still in this. We're still in this problem because I don't know. We're seemingly close. Well, I've reduced it to something that looks NP hard, which is not the best, but I've shown that it's an equivalent problem, which is cool. Right? Like, so if there's any which aren't already. Shown that it's an equivalent problem. Somehow it's equivalent. How are you equivalent? How is it equivalent? Because that's not solvable. Is it solvable? Is it solvable? Are you solvable? If we had a row of questions, right? Take some grid. What about like almost grids? Like take some grid that's like almost satisfies the conditions. Can we biject you? Can we form a bijection somehow? we do with an even number of ones? And fundamentally, like, I mean, every row and column needs an even number of ones. Do we have a grid that doesn't? Oh, what if we count the grids that don't? Then some grid. The problem is it's not independent, so it's not necessarily easy. Because I mean, we're to do some sort of shenanigans. I'm lost. As usual. How does this work? Sequence of operations that can produce that grid. It's a grid with R rows and C columns. Man, stuck on this part. Done all the reductions. Have I done them wrong? Have I done it wrong? I mean, you can fill any two, right? You're going to do everything but that row. And we can simulate you with that. And because of that, we can simulate any two flips. So anything with an odd number of flips, we can do you with one flip and the rectangles. A rectangle can drag the flips anywhere. It's because of how that works. So we can, in fact, do a flip in the top left, and that's fine. So any operations either has no flips and a bunch of rectangles, or one flip in the top left and a bunch of rectangles. Those are equivalent. Somehow, then we must solve the rectangle thing. And flips don't save us from rectangles. Okay, maybe rectangle is impossible. Let's go back to rectangle and flip, right? Yeah, maybe even is impossible. It's equivalent, but it's not easier. It's equivalent, but it's not easier. So what is easier? It's equivalent, but it's not easier. You can bring the flips back in. So the rectangle asks for... It would have been cool if that were the solution, but I guess not. So the rectangle asks for... And we found that this is necessary and sufficient. Found that if we do an odd number of flips, it's necessary and sufficient to have an even number of things and whatever. And if we do an even number of flips, it's the same. I found that we've got to do our flips. We must do our rectangles. Do our flips, do our rectangles. Somehow that works. But we can't count it. Right? Can we? I mean, it's hard to count it. It's necessary and sufficient, but not easier. That's a first. So how do we make it easier? We can allow flips back in, but that doesn't really like... If we have all questions on the last row, then if we have all evens on every other column, then we have an even number total. Which means that to fix the odds on the last row, it's uniquely determined. Uniquely determined and always possible. So if we have a row of all questions or a column of all questions, then we're fine. All we need is even on each. If we have a row of all questions, all we need is an even on each column. Or even on each row, what am I saying? And thus it's always possible. Can we generalize? Suppose we have a question. Suppose we have a single question. We could fix you with an even. Oh, come on, man. I can fix you with an even. What? Suppose we leave one question unfilled on each column, right? On each row, on each column, if it so exists. As long as you're even. If you're odd, it's not, there aren't that many questions. And fundamentally, if you're even and you're odd, then this doesn't work. That's not possible. So we're saying this column must be the same as this row. And this column must be the same as this row. Etc. We're trying to leave some questions unfilled. Can we move questions around? Again, we can move the rows around. If we had all questions, this would be fine. Since we don't have all questions, it's a problem. Let's check stats. We got F2. And we got H. H was easier, or lower rated. I don't know. This is strange. This is really strange. We're close and yet we're not. All the 2 to the k ways of filling up the grid B by replacing each question mark with 0 or 1. Count the number of grids that can be formed by doing the above operation a finite number of times. All we need to do is count. So that's always a power of 2. We're not going to use brute force on this one. I don't want to. Well, maybe, but I'm trying not to. That's the intent, at least. It's because I feel like we can do it without. Because I feel like we can do it without. Be 16. I feel like the answer is often a power of 2. It's always a power of 2. Can we find the power of 2 that works? Suppose we have 2 questions on a column, right? Or at least 2. Okay, let's do some shenanigans. If we have 1 question on a row or column, it is determined. Otherwise, every row and column has at least 2 questions. Then what? Then these guys will form a cycle, right? And if they form a cycle, if we fill in 1 arbitrarily, right? Oh. Okay, I see. So we can remove a question mark. At this point. God damn, this problem, holy Christ. Okay. I'm onto something. Corona, you still here? Are you doing this one? I would assume you don't want to do this one, but my God, dude. I mean, this one is so stupid. Like, there's just so much to do. Hello, yeah. Okay. Can we screw up? No, right? No. Okay. I'm gonna. Okay, we're just gonna guess that it's always possible, and if not, I cry. We're gonna guess that it's always equivalent. Okay. C and end M vector string vs for string s vs c and s. If n mod 2 is 0 and m mod 2 is 0. Okay. If m mod 2 is 0, vector string vs m string n for 0 is while j is 0, j is less than m, j plus plus vs ns ji is equal to vs ij. One. So for string s and s, okay, and otherwise, okay, so set lo what rv cv 2005. Okay, for O equals 0 is n. For it is 0, it is less than 2, it plus plus. What am I doing? NS IJ VS VS IJ. Okay. RVI dot clear RXI is equal to 0. Come on. CBI dot clear CXI is equal to 0. Oh, come on, man. Why are the samples like this also? Like, why do you have to be like that? Okay, we're testing the frickin' 3, 3. You're gonna be 16. Remove you and you, remove you and you. Yeah, okay. CVI.clear CXI is 0. If VSIJ is equal to question mark, RVI.insert IJ, CVI.insert IJ. While RVI.size is greater than 0, PLV is equal to RV upt RV.s upt CV.s cur is equal to cur times 2 mod mod. AR v.f v.s equal to 0. Void out R. If RVR.size equal to 1, AR P.F P.S is equal to RX P.F. Okay. Why? 2. Question 1, question 1, yeah. (101, 000, 110). And how exactly do you think? That's how. That's worse. Why? Why are you not resolving to ones? VSIJ is 1. VLRX CX. So you're initially, every row is 1, yeah. Then you're like this. So row 100, yeah. So then why are you not all forced to be 1? Come on. Because I'm an idiot, that's why. Still? Oh, that's why. CVP.S.raceP. RVP.F.raceP. CVV.S.raceB. Still, eh? How? Oh, because I'm, bro. Okay. CX Thank you. No, that's wrong. Hmm. 32, why? That's why. They're being dumb. I'm being dumb. That's what's happening to me. I'm being dumb. Okay, read into n to m. Vector string vs n for string s vs c into s. If both are 0, if both are even, right, we've proven that you're fine. So do that. Otherwise, if m is even, and as ji is vsij, swap in m, yeah. It's now an even number of rows. String svs, count as 0, x is 0 for car cx. So use question mark plus plus count, otherwise XOR it. Ants is ants. mpow2 count minus 1 mod mod. Yes. Don't need AR at all, but that's fine. For I is 0, do you have 1 second? You're gonna TLE, aren't you? I is 0 up to n, rvi.clear, rxi is 0. For I is 0 up to m, cvi.clear, cxi is 0. Cur is 1. rvi.insert ij, cbj.insert ij. vsij is 1. rxi xor equals 1, cxj xor equals 1. I equals 0, I is less than n, I plus plus. PRI RVI. Yeah. That's plus cur mod mod. And flip you. RVR.size is 1. cxp.s xr equals cxp.s. Right, 2000. Let's test transpose. Read to what? Yeah, bro. This is why you test. Yeah. M equals 2, m equals 3. Every row should be even. You can flip an arbitrary column. Yeah. Okay. Right, this is not going to work in the slightest. But I have hope, because blind hope is better than nothing. Surely. Okay, 1999, 1999. S is equal to string. This is not going to work. This is not going to pass the time limit. Is it? Might it? I don't know. That's 4 million setups. 8 million memory limit.
Yeah, that's a problem, isn't it? Why are your limits so tight? Hmm. Fine. Bool del db. Okay. Deck. Push back. Push back. So while rvr.size and PLP is equal to rvr.front if del p.f p.s else break. db p.f p.s rvr.pop front, and then this is basically all the same. Except we don't do this. dvp.s rvr.pop front rp.f p.s. Yeah, so it's all basically the same. Back or rvr.size is equal to 0. Okay. While cvc.begin front if dv.p.f p.s cvc.pop front so cvc, so dv.p.f p.s equal 1. dv.p.s, yeah, so we do that. We do this again. rvr.size is 1. Okay. Now, dv v.f v.s equal 1.
cool. Great. Mouse break. Mouse break. Come on. Why? So you should be here. Zero, zero, 1, 1, 2, 2. Right? So column 0. So RX, CX, right? I don't need AR at all, but whatever. CXP.S, XOR equals RXP.F. We're doing this twice. Okay, this is where this could actually be useful. Good. Okay. I'm scared, but whatever. I mean, you're running time, right? Yeah. No. What? Wait. Okay, that's fine. Barely. Are you correct is the issue, right? So, I mean, you should be 4. Yeah. Yeah, okay. This isn't gonna work. We're gonna need some stronger tests, but we're gonna submit anyway, because why not? We're answering test 9. Yep. So there are 3 different codes that we would have to debug. C into N to M. vector string VSN 5 5. How many should you be? So 1, 2, 3, 4, 5, 6, 7. So 256? Yeah. You're doing mod. You have the right mod. My god, dude. Ugh. Should be 4. Yeah, alright, so you're going to be removed. Wait, that's wrong. No, wait. I mean, surely it's some bookkeeping stuff, but yeah, so column 0 and columns 1 and 3. Yep. This works, this doesn't, because, why not? Actually, why not? Alright, we have free reign here. I can make you 0, make you 0, make you 0. I can make you 1. Oh, no, we couldn't, yeah. There's no way. Here, though, we totally could, right? That works. Yeah. Why only 32? Right, 1, 2, 3, 4, 5, 6. What? 1, 2, 3, 4, 5, 6. Yeah. Okay, what's wrong with that? That's interesting. What are you doing? What are you doing? Wait, what is this? Oh, that works, huh? Oh, that works. Why not 3, 0? So you've all been deleted. PRDV. Two zero. Why have you all? Oh wait. Oh, that's correct. Okay, I see. Damn, it's correct. That's a shame. That's a shame. That's a shame. Ugh. Wrong answer in test 9. That could be literally anything. Let's write a stress, I guess. Well, no. How do we even write a stress? Oh god. Okay. So we didn't test this. And we didn't test it. Should be 16, but like we didn't test it. N mod 2 is 0 and M mod 2 is 0. C is question mark, ants is ants times 2 mod mod. Do that, be done. If M mod 2 is 0, NSJI is VSIJ, VS equals NS. N mod 2 is 0. Ants is 1. For string SVS, count is 0, x is 0. For each question mark, increase the count. Otherwise, must mess with the XOR. If count is 0, then this XOR, the other XOR is not reachable. Otherwise, ants is ants times mpow 2 count minus 1 mod mod. Yes. Ants is ants times pause 0 plus pause 1 mod mod. Okay. So it's here, as expected. Rx is VLN. Do we get to a large test? No. Ants is 0. IT is 0 up to 2. IT plus plus. DV, yeah. RVI.clear. CVI.clear. Let's do some like weird ones. Let's just test these. Okay, yes. Probably still 1, right? Or 2. Are you still 1 though? We can make you 0 and that works. Or we can make you 1, right? Yeah, we can make you 1 and just flip all of you, and that's fine. Yeah, that works. It's probably bookkeeping, man. It's probably bookkeeping. All occur is 1. I0 is then I plus plus, so you're a question mark. Yeah, that's fine. Up to RI, up to CI. Okay. For I0 up to N, while RVI.size is greater than 0. PLV is RVI.front. DV.v.s, v.f, v.s is 1. Up to R, up to C. Cur is cur times 2 mod mod. So if RXI or CXI, pause is 0. If pause answers answer plus cur, VSIJ is not equal to question mark, then flip it. So I need to be here, right? So PLP is RVR.front. If DV P.F P.S, DV P.F P.S is 1. RVR.pop front. If you're a question mark, set you to this. CXU, RXU. And that's fine here, right? Yeah. RX. So we set you equal to the rows, which is fine. Doesn't matter. Up to CP.S. DVP.F.P.S or RVR.size is 1. Okay, well CVC.size. DVP.F.P.S is 1. CVC.pop front. Yeah. Yeah. Okay, so we're gonna have to write a stress. Okay. Cool. Why? Okay, so everything should be removed here, right? CVI is 2.3. C is 3, P is 2.3. What? No. F is 2.3.2.4. Wait, okay, wait, what? Okay, so this should actually be fine. So you should be deleted. No, you should be deleted. PRC PRVP.F 2 CVC.pop back. What are you now? Right, so now you should be being deleted. Yes. One zero one one. Now you should be being deleted. Yes. Now we delete 1 0. R's are RVR is that. CVP.S is 0010. dv is 0, 0, 0, 0, 0. 1, 1, 1, 0, 0. Okay, you should be deleted. That's true. Now we call CV on p.s. Oh my god. How? How did I miss that? How did I miss that? How did I miss that? How did I miss that, man? Okay. Submit again, I guess. How did I miss that? How? My eyes are glossing over it, I guess. Nice. Cool, man. Cool. Okay, so I do 5, 5? Probably not, right? Oh yeah, that's fine. Damn. Okay. Okay, where? Why? Stop it. Where are you being printed? God, I have so many frickin' prints. Okay. Good. Okay, thank you. Thank God. Thank you for finding a case. We're overcounting. God, I really did not want to have to debug that blindly. So this problem's fun. Jesus, man. Yeah, I am eating. It's just a weird schedule that I'm following. Okay, so we have one test case. Okay, good. Thank you. All right, why? So what's happening? I mean, first of all, how many things do we have? So remove one. Remove this, remove this, remove this, remove this, remove this, remove 2, remove 3. Oh, it's a bookkeeping bug. Okay. Okay. Y is 16. So I is 1. Cur is 8. Then this should be removed. This should be removed. This should be removed. This should be removed. Wait, what? Wait. Remove you, remove you. That removes all of you. Remove you. How are you not unique? So remove you, right? Are you serious? Wait, now wait. Damn. No, you should be, right? Remove you. Remove you, remove you. Remove you. Wait, what? Wait, remove you, remove you. Remove you. Remove you, remove you, remove you, remove you. Remove you. Or we remove these 3. Wait, so you're gone, right? Somehow this is not unique. That baffles me. Somehow this is not unique. How are you not unique? I'm sorry, but what? Are you kidding me? That was like my final assumption. That was my last assumption, my last hope that this would be unique, and it's not. Are you kidding me? Why are you not? People solve this in contest time. That baffles me. That's actually crazy. I find that genuinely crazy. People solve this in contest time. Wow. Man. So, like... Okay, you're gone, you're gone. We know that. So might as well replace you, right? Might as well simplify it. Wait, what? Oh, because one of you is not possible. Oh, yeah. Sure. Doesn't matter. That's not the point. Okay, whatever. Yeah, sure. Not the problem. The problem is that this is weird. So we don't need you either. You can be this. Damn. I guessed wrong. Why did I guess wrong? Oh, right now that gets rid of the issue. Why is this an issue? Somehow this is not unique. So if you disconnect the oh my god, dude. Okay. So This is so ridiculous, dude. Oh my god. How many people freaking solve this? In contest? That's crazy. That's actually crazy. I got a lot of solves. I got a lot of solves, man. I'm missing something. Or this is well known, but I don't know, man. It is actually crazy. It's actually insane. How? How? I don't know. I mean, you can get the general. Just, oh my god. Okay. I mean, that's wrong. What? So we need to remove leaves from a spanning tree. Which is like very painful. If you're 1, you're a leaf by default. Okay, so vector pl edge. Edge ij dot pushback last j last j. No, wait. Yes, okay. Yes. Bro, are you kidding? This code is long. Yeah. Okay, let's run it on the first sample because we're gonna have to debug it on there anyway. What? What do you mean? They're multi-tests. Yes. You're not being used. What? Are you serious? Great. Okay, it's equals 2. Oh, we need a frickin'. Okay. Stop printing so much. Okay. Jesus. Okay. Good. Now I need to do the freaking constant opt again, because pain. Oh. Awesome. Yeah, great. What? Did I have a bug somewhere? That's not correct. Okay. Oh, it's because of the... No, it's not. What? I need break anyway. God damn it. How do you use that much memory? I wouldn't be surprised if you were bugged, but what? That's awesome. 0011. Okay, there's got to be a fundamentally better way to do this. This is absurd. Like, just go through the frickin' question marks and do it, man. That's it. That's all you have to do, right? You get this, like, complex structure. Actually, what's wrong with this one? So we can say this can be anything. We can say this can be anything, right? We can. What's wrong with this? Wait, something's, like, very wrong with this. There's something's wrong with the idea. That would be a shame. Be quite the shame that... Be quite the shame if the idea was wrong. But it might be. I mean, you can be anything, you can be anything. You can be anything, you can be anything, right? Like, why not? Like, why not, right? Because then you'll fix the mistakes for this one. Oh. 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 And so the answer is clearly a power of 2. I mean, there's some that are free and some that are not. A block of questions isn't actually free, is it? Well, you're going to do something to both. Wait, like 3, 3. You're not free. I don't care about what res is. Oh, that's why. Wait, but is that even possible then? I feel like it works by accident, which is cool. Yeah, if we do a flip, then it doesn't work. Sure. Why does this work? Works because if all of these are fine, then the rest of you are fine. But I mean, this could screw us over, right? Like, this could screw us over. Be careful with this. But it's not going to screw us over because they're going to choose it carefully. So the fundamental issue is this could screw us over for here. And we have two independent subproblems here. And you need to be chosen based on this. Otherwise, it screws over at least one of these. When is something determined? We can assume we can always unscrew something up with the question marks. But what is that? What is the exponent? What is that power of 2? It's gotta be something. It's gotta be fairly large. Can't just do a freaking spanning tree, apparently. This feels like it's I don't know, it feels kind of well known. I feel like this feels like it's a problem I would have seen before. Just like assigning the question marks to make this work. This feels standard-ish, which is a shame because it's hard. It's very hard. How does this work? How does it work? How does it work? How do you work? How do you work? How do you work? I have a conjecture. I have a conjecture. Yeah, we're gonna put all you in here. You're never going to work, but we're gonna put all you in here. Just gonna make this function empty. Do this here. Stop. Okay. Gonna get rid of all of you. Great. Alright, of course. None of this is going to work. I need a more concrete strategy. Need a more concrete strategy. Don't I? Yeah, this separates. Okay. I mean, somehow we have to do something with the spanning tree, right? So I mean, if removing it doesn't disconnect the graph. That's ultimately what we're dealing with, right? If removing it doesn't disconnect the graph. And this is fine. Then we can do whatever we want with you. If removing you does disconnect the graph, then that's bad. So when we have a graph, we can remove the... We have a graph. We can remove any node from it. We have a graph. We can remove any node from it. If you're a leaf, then we... If you're not a leaf, then we multiply the answer by 2. If you disconnect the graph, we can't do that. Okay. This could work. I actually have faith in this idea. Okay, so we get rid of all of this. It was all stupid. 0.16, 0, 2, 3, yes. 2, 2, 1, 2. 1, 4. But how? How are you a leaf? How are you a leaf? Tell me how you're a leaf. How is this a leaf? So 0, 4, 0, 0. Well, that makes no sense. That explains a lot, actually. How then? How? Zero, 0. Oh, wait. Okay. I see. That is actually fine. Zero, 0, 0, 4. Sure. 0, 4, 1, 4. 1, 4, 1, 2. 1, 2, 2, 2. 2, 2, 2, 4. 0, 0, 3, 0. Sure. Then you walk this, right? So we do 2, 4. Oh. That's why. Okay. Alright, we run it again. Nice. Wait, do question marks not fix everything? Wait, why? What? Oh. RVI.clear, CVI.clear, DV is reset, RX is reset, CX is reset. I don't know what R is. R is reset, yeah. Edge2.clear, yeah. There we go. Indeed. Okay, but like what else? Dag is reset. AVS is reset. Canned is reset. What? Okay, this is a genuine issue. CXC XR equal RXR. Okay. That should handle the impossibility case. What? Oh, come on. Okay. If RXR is equal to 0. Still. What is this? What? Okay, so somehow this is completely breaking. CRR. Okay. Finally. Are you going to be correct, or are you going to crash on the 40,260th test case? Or am I printing? Printing everywhere, but like, where am I printing? RCIJ, RCC, RCC. IJ last. Yes. Okay. Now we need to run you. You're gonna Emily, right? Yeah, you have no shot. Why are your constraints so big, man? I don't understand. Why are these constraints so large? I mean, this is NM. This is NM with a very big constant, but it's NM. Such a big constant. Such a big constant. It's an absurdly large constant. And do you have the memory at least? And they're gonna have to watch out for overflow everywhere, but still. Yeah. No, you don't even have the memory. What? Wait, why? Okay. You're finally passing all cases of size 5, which is promising, but I can't even get it to fit in memory, so that's great. Okay. Mild intermission. Good. Stress tests, love them. Okay, we don't need this at all. Just get rid of you entirely. What is TV? Oh, we don't even need you. No, I might as well. Okay, yes. Don't fail. Do not fail on the 500,000th test, please. I mean, that's all of them, right? Like, that should be all the tests. Now, it's 3 to the 25, actually, so... Yeah, it's gonna crash my terminal. ID... P... R is equal to P over M, C is equal to P mod M. Okay, stop. Comp. Good. Okay. Okay, it should be a lot less. Where? Where is this memory coming from? Oh. It's this. Okay, well, damn. Wait, why? Wait, why use so much, dude? Vector VL deg. Vector int. Are you better? Do you help? You don't help that much, right? Why? Deg is equal to vector. Fine. Are you better? Then you got a TLE, right? I mean, it's freaking 4 million. I hope not at all. This is very painful. I will say, this is very painful. Let's try 17. Because that might help with the vectors. Yeah, but it's slower. Okay, so... How big is canned? Let's get rid of canned and see. Not at all. Not even the slightest of the problems. It's edge, isn't it? Why did you have to be 2000? Why? Why, man? I mean, I understand that, like, you didn't think something like this would happen. Something as stupid as what I'm doing. I'm actually this is linear, man. This is freaking linear. This is so annoying. This is literally linear. Um okay. I know what I have to do. I know what I have to do. Const LDR4 is equal to 0, 0, negative 1, 1. Const LDC4 is equal to okay, so we don't need edge at all. I'm just going to get rid of it. I'm going to get rid of edge 2. This is so stupid, by the way. It's absurd how stupid this is, but we're going to do this because this is dumb. So for d is 0, for lt is 1, t we are solving this problem, and then we're going to bed. That's the plan. NR is equal to R plus dr d times t, and C is C plus dc d times t. If not valid, NR and C break. If what is it? AR. Yeah. ARIJ is equal to question mark. If not avis, break. IJ. Then avis IJ is 1. Edge 2. Wait, D. RC D is 1. RC D XR1 is 1. Okay, and then let me do RMV. All right. So for LD is 0, D is less than 4, D plus plus. If edge 2, P.F, P.S, D. If ARIJ is equal to question mark. Minus deg IJ, if deg. ij less than equal to 1, can.push back id ij. Okay. p.s, p.f. I'm missing a bracket. Okay, compile. Compile. Oh no, are you serious? Wait, no, don't crash my terminal. Okay. Please don't crash my terminal. There's no way this code works, right? Yeah. Oh, you actually, okay. Does this code actually work? Like, will this code actually work first try? No, it's not, 'cause it's not gonna friggin' read it. CNS. Wrong case. Let's try on a big one. Yeah, that's about right. That's about right. You're gonna be 0. Why are you 0? It's a shame to assume this code would work on the first try, but still, worth a shot. Break. Here. Break here. Oh, it's because it shouldn't be 0. Should not be 0. Why are you 0? Why are you 0? Could you not be 0? Could you, like, not be 0? Could you please not be 0? I'm sorry. What? What changed? What changed, sir? What changed? What do you mean 2? Are you hard coding? I'm so confused. What is going on? What is going on, man? What is going on? Okay, so you're 0. We're gonna print canned, and you're going to not print 512. Okay. So Rx and Cx are the issue, right? Yeah. Why though? So I'm not resetting edge 2. Edge 2 ij is equal to array bool 4. I mean, that's not the issue, but what is the issue then? Why are you being like this? What is AR? Oh, you're like not getting any of them. Wait, no, wait. No, this is fine. AR is useless. What is cur? occurs 256. Yeah, I mean, that's correct. It's just this that's wrong, right? CXRX. Are you getting all of them? So 0, 0, 1, 1. 0, 0, 1, 1. That is fine. 0, 0, 1, 1. 2, 3. 4, 0. I need a frickin' work. 32. Yeah, 32. Damn. Okay, I didn't want you to work, actually. Damn. Why? Okay, good. So you're not fixing this. So R equals 2, C equals, okay. Yes. A vis ij is 1. Blah. Perfect. Okay. Good. Okay, let's run it a few 100,000 times. I lost it. What? What do you mean? What do you mean unused? The hell is that? What was that? Did it compile the wrong thing? I don't... what? RCRXCX. Here. Okay. That's fine. Yes. Stack overflow. How? Are you kidding me? Just make everything int. Stack overflow with linear stuff. Linear, by the way, linear. This is linear. it's a constant thing. Yeah, I mean, it's just a constant. I've never had that before. I've actually never had that before. That's wild. That's actually crazy. So that's where the memory's coming from? Okay. Do you work, though? Oh, not keyed on a D. Not Avis IJ. Yeah. That's not the issue. What is the issue? We have to debug BFS. You serious? We have to debug BFS. Why do we have to debug BFS, man? This is absurd. This is all for, what, 3100? This is crazy. Two. So what are you? So you need to be 1. You need to be 0. You need to be 1. Cur should be 1, right? Cool. Cur's 2. Why is cur 2? That's a problem. Cur should not be 2, right? Because, like... Cur should not be 2. Yeah, cur should not be 2. Not valid ij break. If rij is equal to question mark. If not avis ij. Range 2. I mean, it's a spanning tree. We're taking an arbitrary spanning tree. So 0, 1, 0, 0. Sorry, what? If vsij is equal to question mark. Why was that not an issue before? That's interesting. Okay, whatever. I don't understand why that wasn't an issue before, but fine. Let's run you a few million times. Okay. That is not my concern right now. My concern is getting this to pass. Okay. Sure, I'll take it. I'll take it. Hey, okay. And you're going to be correct, right? Because you're passing all the tests of size 5. Don't time limit exceed on test 69, please. Thank you. Thank you, man. Thank you. What a 3200. Holy Christ. We're done. Absolutely done for today. I mean, Jesus Christ. Okay. How do you get out of... You can't solve any on div 4s? Yeah, I mean, it was gonna work. It was... It was gonna be correct. Look, I ran it on like 3 million small cases. It's just freaking... Oh my god. Okay, so like... Whatever the hell happened to that, I have no idea. I don't know why I struggled so much and 20 people solved this in contest. But whatever, I guess. I feel like this is kind of known. Like, I feel like you could have used standard ideas to build up to this. Like, I feel like I've seen a problem like this before, where you have to... Like, the problem reduces to... count the number of ways to fill in the question marks so that there's an even number of ones in each row and each column. And... Oh, it's so dumb, man. It's so dumb. Has anyone sniped me on this problem? No. No one would ever think to do this. Okay. I feel like that's standard. Corona, if you ever come in, can you like tell me that this is standard so I can feel bad about myself? Yeah, okay. If you can't solve any in div 4s, I mean, can you do them in practice, I guess? Like, that's mainly the thing. If you can't do them in practice even, then it's probably a programming issue, because, I mean, they should be pretty straightforward in the beginning, at least. Typing speed, I don't know, 100s. I don't want to... I do a test, but I don't want to do it right now. Like, screw that.
What's up, Nick? What's up, Mark? Recognize you both. Nice. Probably not here anymore. 9-hour sessions. Yeah. This one's 10.5, I think. I'm still streaming. Okay. All right. So, per a request, I'm making a document with the stuff I'm doing. This is in the description now. It is not in the description yet. It will be in the description right now. I'll put that here. Links still don't work, I'm pretty sure, but whatever. Just, yeah. Okay. So I'm going to update this when I get off, and then, yeah, that's the plan. Tomorrow, same thing. That's it. We're doing the same thing. We're grinding. We're going to try and do better on AtCoder. I have no idea. Same channel, same deal. I will not put it on Codeforces anymore because it's going to get spammy. So if you want notifications, join Discord in the description, or subscribe to this channel as well. I think that's it. Yes. Hope you enjoyed. I did not. I did not have fun today, but freaking what, 500 line code? Crazy. All right. See ya.